Great. So I hope it's clear. Yeah, the voice is clear. Great. Great. You guys can see my screen? Yeah. All right. You can see the presentation. Can you see the Excel? Presentation only. Now you can see the Excel, right? Yeah, perfect. 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 All right. Great. Great. All right, so let's begin. Yeah. Good evening, guys. Good evening to guys in the east, and good morning to our guys, to our friends in the west. Yeah. So early morning. All right. So all set for this lecture, yeah. This is my favorite topic: statistics and probability and regressions, right? So I really love this topic, and I hope that I can inculcate that love in you guys for this subject. No, and it's very important for any, if you want to be a quant trader, statistics, probability is key. Yeah, you cannot imagine to be successful in this field without a very sound knowledge of statistics. Yeah. Okay. Just to be clear, this lecture is there are a lot of quite big. So there are a lot of topics that I will cover. It might seem very moderate in the beginning, but slowly and steadily the level of this lecture will go up. Again, please pay attention, right? If you, I mean, that's fine. If you did not get a concept, I can repeat it, but don't be very casual that, what, if we don't understand, we'll ask him to repeat, because this can be a long lecture, right? And as usual, I will just request everybody to keep their questions related to what we are studying, right? As I said, you can email me offline for questions that are not related. That's fine. But if we waste time today on questions that are not related, I'm telling you, we'll be here half an hour extra, right? So let us keep it there. Lecture of SFM was not completed. Why do you say that, Rishabh? It was completed. So if there are a couple of things that I will cover in my trading system, but SFM was done. Everything that I wanted to complete was completed, right? There are a couple of things in Excel that I will tell you in my last lecture, right? All right. So let us begin, right? So just to tell you what all will be covered in this lecture, I will start with the very basic concepts of statistics: mean, median, mode, whatever, right? Variance. Right, and I will quickly move on to probability theory. Now, probability theory is absolutely essential, right? So you will use it a lot in option theory, a lot in different strategies, right? So probability, I would really want you guys to pay attention to probability theorem. Then what I'll do is I will give you some examples on how statistics can be used in the world of finance, right? And through those examples, I will tell you, the usage of statistics and how, why statistics is so relevant in the financial world. And then finally, what I'll do is I will just introduce you guys to the concept of regression. Right? Regression is nothing, trying to measure the relationship between two variables, right? And finally, we're talking about statistics, right? So we can get a lot of statistical results and whatnot. So towards the end of the lecture, I will just tell you that once we've got the results, right, we should know whether they are significant, right, whether they can be believed or not, right? So there are tools to know whether the results that we've got can be interpreted. How can they be interpreted? All right. Okay. First things first, right? Statistics. How does statistics help us? It helps us discover relationships, right? Relationships between two variables, right? Not the relationships between human beings. That's a bad joke. Anyways, so it helps us discover relationships, right? If Microsoft has gone up by 5%, will Google follow, right? Or vice versa? Is there a relationship between Nifty, the Indian index, right? Nifty and its components, right? What is the relationship? How do I know which is leading, which is lagging? So all these things are quantified through statistics, right? It helps us measure the financial world, right? What is the return on this stock, right? Average. What is the risk if I hold this stock for too long? Okay. So essentially it helps us measure, quantify the financial world, right? If we have a knowledge of these things, right? What is the relationship between two variables? What is the risk? What is the return? We can sort of beat the market, right? We can beat the odds. And statistics is not related only to the financial world, right? It can be used day in, day out, right? So, I use it in every, if I think in terms of statistics, right? If I meet a friend by chance in a cafeteria, right? What was the probability of me meeting this guy, right? So it can be used everywhere to understand this world, right? It helps us think smart, right? And hopefully getting richer, right? All right. Yeah, getting richer. What now? So just to sort of underscore the importance of statistics while we are dealing with data. So okay, let me just show you something. Can it be used to beat the odds in horse racing? Why not? All right. So this is the daily end of day closing prices for NSE. NSE is India's index, top 50 companies by market capitalization in different sectors, and this is ACC. ACC is another stock part of Nifty 50, so it's a component of NSE 50, right? And these are the closing prices of end of day. Right? Now, data in its raw form, right? These are just numbers, right? Are they telling me anything? Not really, right? So I really cannot make out of this data, right? I cannot make anything out of this data. I need to sort of summarize this, right? So what I do, I calculate the daily returns, right? These are the daily returns. And what I do is I calculate the average and standard deviation. So as soon as I summarize, and are we going to use this, just concentrate on this Excel. This is more of a theory class rather than a practical session. So, don't worry about having this Excel or not. Just, please make sure that you're concentrating on the screen, right? So as soon as I summarize it, I have an average return of Nifty. So on a daily basis, this tells me that Nifty went up by 0.01% in these 10 years, right? With a standard deviation of this. And ACC went, the average return of ACC was less than Nifty, right? And its standard deviation was more. So there's a standard deviation formula, right? So it's calculating the standard. Now, this also does not give me a very nice, picture. It summarizes the data. Yes, statistics helps me with that. But as soon as I plot them, so, visually, if I see the data, right, then it's sort of, a lot of ideas can come in your head, right? So the blue dots are Nifty, red dots are ACC. As soon as I look at this chart visually, right, I see whenever, these two are sort of together, right, going up and down together, except for this major period, right? And it tells me that probably if one has gone up and the second one has not, maybe I can, they will probably revert to each other, right? It's like like snakes, just crawling together, right? So maybe here in 2012, I could have shorted ACC and bought Nifty, and we could have profited, right? Or there might be a lead lag behavior, I don't know, but definitely they're sort of moving together, right? Can I go over column D? Yeah. So this is just the simple log returns, right? Log returns because I'm assuming annual compounding, right? All right. So they are simple returns. You can do it simple returns. I've taken log. It's not a big deal, right? So data in raw form does not tell me any story. There's a question: is Nifty 30 closing price the average closing price of all 30 stocks or total? No, this is Nifty 50. This is so. The index is traded, so it's the closing price of the index, and the price of the index is actually calculated by the weighted average of its components, right? But that is not important. The index is traded, so we know the closing price of the index, right? So visual representation of data may tell me something about the data, right? Are they going together, right? Is one stock leading the other or vice versa, right? And obviously statistics will help me summarize the data, right? It can tell me the average. It can tell me the spread, right? How was the data, what was the spread of the data, right? So how is it distributed around its mean, right? So if the mean is, say I tell you that, this stock is on an average going, the price is increasing 10% every year. How many times was it? 10? Was it, were there some years where the returns were negative? So what was the spread, right? What is the variance or the shape of distribution, right? Now, to visualize, you can have histograms, you can have time series plots. Frankly, it doesn't matter. It's up to you. I usually love time series plots a lot, so I use them a lot. But it's up to you, right? What tool you use to visualize the data. But the most important thing is when we visualize the data, we can make hypotheses, right? We can make a hypothesis. Now, what is a hypothesis? A hypothesis is an idea that we can test, right? It's sort of an assumption that we can make to sort of if the idea is true, then probably we'll be able to make money out of it. So the idea can be, Nifty and ACC are sort of going together, and whenever they are apart, right, I can short one and long the other because they will sort of converge back to each other, right? So this is an idea. This is a hypothesis. Or if I see that, if Nifty goes up by 1%, ACC will go up by 0.8%. This is the hypothesis. So statistics will help me test this hypothesis, right? So this is a small data pyramid that I use to, to underscore the importance of statistics. So at the base of this pyramid, we have raw data, right, which does not tell me anything. From raw data, we extract information, right? What were the returns? Basically the hypothesis, right? What was the returns? Is there a lead? Is there a lag? We test this information thoroughly and we get knowledge, right? Yes, maybe whenever Nifty goes up by 1%, the next day ACC will go up by 0.8%. Right? So this is knowledge. And I will apply this knowledge in the market, will get wisdom or money or whatever. And I can climb this pyramid through statistics only. So statistics will help me extract information from the data. It will help me gain knowledge and then apply that knowledge in the markets. How is that different from the alpha of ACC? They are very different. Towards the end of the class, I will tell you. Please don't, let us not distract ourselves from something that was not taught. All right, so this is how you can visualize it, but I will cover alpha and beta and whatnot. Okay, so you can have a lot of ways to visualize the data. What is a sample and a population? Now, this is an important concept used to backtest hypothesis. Right? I need historical data. If I have a hypothesis, if I have an idea, right, I need historical data to test that idea, right? But I might have, if I'm in the US, right, I can have data for the last 50 years or even more than that. Do I really need to test my idea on the whole population of data, right? Last 100 years, 50 years? Not really, right? So what I can do is I can take a sample from that 50 years of data, right? And test my hypothesis on those samples, right? So I can take data from 2008, 2009 when the market crashed. I can take data from 2011 to 2014 when the market really, boomed. Data from 2001 crash and whatnot. So I can take sample. Now, what is a sample? A sample is a representation of the population, right? It looks like the population, right? So to give you an example out of the from outside the financial world, right? When we have elections, right? A lot of these media houses give you data on what is the mood of the nation, right? Where are they? For which party would they vote? Now, what they do they ask every citizen of the country? Not really, right? They pick out people, right, from various parts of the country, so that those parts that they are picking sort of summarize the whole population, right? And they try their best that whomever they are interviewing sort of represent the country, right? The whole data set that they're picking up. So they might interview like 20,000 or 30,000 people, right, out of a country of 1 billion, right? But their idea is to make sure that the sample that they interviewed has the characteristics of the population, right? And that is how their predictions would be close to the actual result, right? So there's a simple flow chart that we have. So this big blue box on the left is the sample, is the population. We take a part of this population, right? This purple box. Okay? So this is the sample. And we assume that, this sample is very close, the characteristics of this sample is very close to that of the population, right? And we can pick different parts of the population so that the sample that we have is a very representative of the population. We observe this sample, right? Summarize its characteristics, test our hypothesis on this sample, see whether it is working or not, and then we infer about the population from this sample. Is this clear? Yes or no? Any question? Why we test on historical data? Because we cannot test it on future data. No, I mean, because the basic assumption is that history will sort of repeat itself. Yeah, that is, I mean, in any strategy that we come up with, right? Until unless it's a pure arbitrage strategy, right? We assume that yes, history for some time will definitely repeat itself. For that matter, I mean, people a lot of times give give a lot of flack to statisticians, right? That you assume that history will repeat itself. In this universe, there is no law that does not assume this. Even Newton's first law, second law, third law, they are only based out of statistics. They're only based out of observations that are just repeating themselves. I mean, there can be another universe where Newton's first law or second law don't hold up. Or there might be a day where something happens and they stop holding up. But that's fine. I mean, they're not, nothing is set in stone. So we always assume that history will repeat itself, right? Any theorem is just, any theorem for that matter is just statistics at the end of the day, right? Yes, it is true that because the population is pretty huge, so we need not test our ideas on the whole population, right? It's only the sample that we test our hypothesis on. All right. All right. So much for statistics in its. So this was just a brief introduction, right? And we will, as we go on in this lecture, we will sort of work our way around how to test our hypothesis, or how to interpret the results, and how to use statistics in the financial world. But before we get there, I want you to introduce to the concept of probability. These are my personal opinions, but I think probability theory and the theory of evolution are the two most important things in this universe. Only my opinion. It's a very arguable, I mean, I can have a lot of debate on this, but simply my opinion. So, but having said that, there is no doubt that probability is very important in the world of finance, right? So please pay attention. By the way, any questions so far? Yeah. How do we know if the sample is good enough? So I will sort of take you through that in my last lecture on trading systems, but just to give you a brief idea, right? So, we know when the market has boomed, when the market has tanked, when the market was flat, and with what times was the market very volatile and what not. Right, so we try to pick all these data points in our sample, right? So that's why I mentioned 2001, 2008, 2009, 96 to 99 when the market was really booming, 2011 to 2014. So based on the geography that you are working in, right, and how the index performed, you sort of know that how did the markets perform, and you want to pick data points from all those years, right? So that you have pretty much you've covered everything, right? Each phase of the market, to say, right? So I mean, this is my opinion. My probability theory and the theory of evolution. Don't even go to that. I mean, I was just I really want to highlight the importance of probability in the world of finance, right? So probability is very important. How is simple returns related to log? This is a good question. They actually have different assumptions. Log returns assume continuous compounding. Simple returns don't, by definition. So if there is continuous compounding, then the returns are e to the power, the time period and the rate, right? So that is why for returns we need to take the logarithm. This is you can just Google it if you if you don't know continuous compounding. If you still are because this is, I mean, anybody who's familiar with continuous compounding would know that how to calculate what is the formula to calculate continuous compounding. If you face any problems, I'll be more than happy to help you out, right? Just send me an email and I will tell you why it is. But this is simple continuous compounding, why I take logarithms. All right. Uh, if we talk in percentage, roughly sample is how many, what percentage of the population. It's not percentage really. When I discuss the trading system, I will tell you thumb rules that I use for samples and whatnot. Right? How if you have an idea how to backtest it, I will clear all your doubts in my class on trading systems, right? So right now you just need to know that we don't need to test our hypothesis on the whole population, right? A sample is a good way of doing it. All right? Okay. Guys, you can hear me, right? I mean, is my voice breaking or am I clear? Yeah? All right, perfect. 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 Okay. So I guess I've answered all the questions, right? So we'll move ahead. Okay. Probability, right? Probability will help us making decisions under uncertainty, right? Because we cannot predict the future. There's, I am a proponent of chance, right? So I don't believe in determinism, right? So probability is very important, right? And in any case, financial world nobody can predict, so it's all about probability, right? It helps us understand the risk and the expected value, and we'll talk about all these things. What is the definition of how do I understand probability? It is the likelihood of an event happening. As simple as that. As simple as that, right? Chance or likelihood of an event happening, right? How do I calculate it? I count the number where, so if I want to calculate the probability of something, right? I count the cases in which that event will happen and I'll divide it by the total number of cases. So just, a simple example. What is the probability of getting a 1 if I roll a fair dice, right? So you would all know, right? So it's 1 by 6 because there are 6 cases. Either you roll a 1, a 2, a 3, a 4, or a 5, or a 6. Right? So 6 cases. And I need to know the probability of me rolling a 1. So it's, the only case where it is 2 is 1. In the case when I actually roll a 1. So it's 1 by 6, right? Probability if I'm tossing a coin, right? What is the probability of getting heads? Half, right? So you guys are familiar with this, right? Yes or no, guys? Guys, yes or no? Yeah? Okay. So what is the probability of drawing an ace from a pack of well shuffled cards? 52 cards. So 4 by 52, right? 4 by 52, guys, because there are 4 aces. Right? So 4 aces divided by 52. Right? Great. Great. There's a concept of odds in favor and odds against. It's just a definition. A lot of times it's used in casinos and betting circles. So I just wanted to get you familiarized with it. It's just a different definition of how probability can be calculated. So odds, if you know the probability, then you can of an event, you can calculate the odds in favor of that event by just dividing the probability by 1 minus the probability. And odd against is the inverse of it. Right? It's just a different definition, right? So, right? So Charles, it would be 1 by 13, right? 4 divided by 52. So odds of drawing an ace is 1 by 13. So odds in favor of drawing an ace would be just by definition, right? Probability divided by 1 minus probability. So the odds in favor would be 1 upon 12. Right? And odds against would be the inverse of that, so 12. Right? Right, so is this clear? Yeah, odds in favor and odds against are clear? So a lot of people would be like, you dude, hey, I know all this stuff, right? What's the big deal? So let me ask you a simple question. There are so. Do you guys know about? Have you heard of a ceiling fan? You guys know what a ceiling fan is, right? Those fans that are hanging from the roof, right? So, Kaushik, what do you want me to repeat? So, I just don't want anybody to use my ace. No, so the probability of drawing an ace from a pack of well shuffled cards. So, probability is simply the counts divided by the total number of cases, right? Counts in which the event is true. So there are 4 aces in a pack of cards. So 4 divided by 52 total cases, right? So it's 1 by 13. Yeah, is this clear? Right? All right. So, and then if you know the probability, you can calculate the odds in favor and odds against by simply plugging in probability, right? So that's simple, right? Now, let me ask you a simple question. So you guys know what a ceiling fan is, right? So there are 2 cases. Either the ceiling fan will not fall or it will fall, right? Only 2 cases. What is the probability that this ceiling fan will fall off the roof? So people are saying half. This is the question, are odds and probability different? Yeah, it's a different, odds is probability upon 1 minus probability, right? So just another, if I know the probability, I can calculate the odds. If I know the odds, I can calculate the probability. It's just a different way of telling me the probability, right? If I tell you that the odds of something are 1, then I know the probability is half, right? So I can calculate the probability if I know the odds and vice versa. Right, Nathan? Odds, so the reason why I don't like this slide is because people get into odds and whatnot when it's only used in betting circles and it's not used in financial world. But I'll just tell you, it's just a different way of defining. Of telling you about probability, right? It's just it's like, if you know the probability, you can just calculate the odds, right? If I tell you that the probability of an event is half, then the odds would be half divided by 1 minus half, which is 0.5 divided by 0.5, so it's 1, right? So odds in favor of that event is 1, right? So it's as simple as, there's nothing more to it, right? If I know the probability, I know the odds. It's because I can calculate it through this formula. It's simply that. Is this clear? If the probability is half, if the probability is 1, then odds cannot be calculated, because 1 upon 1 minus 0 is, frankly, if the probability is 1, then I don't really need to calculate the probability, right? It's certain to happen, right? Is this clear? So, all right. So coming back to my question about the ceiling fan, right? So some people are saying half, some people are like, I need historical data and whatnot. But why is it not, if it is not half, why is it not half? Right? There are only 2 cases, right? Either it will fall or it will not fall. Why is it not half? If somebody asks you this question, right? And I'll tell you the reason, and it's an important thing, right? And one of you guys have actually got it. Whenever we are calculating probability, it is very important that whatever cases we are deciding, right? So there are 2 cases, whether the ceiling fan will fall or it will not fall. These cases should be equilikely. The chances of these events happening should be equal, and only then can I divide, right? So I can count those cases and divide by the total number of cases if those cases are equilikely, right? Very important thing to understand. I cannot calculate the probability if these cases are not equilikely. In the case of the ceiling fan, these cases are not equilikely, right? So it's not half. All right, clear? It's not about dependent or not. I didn't say dependent or independent. It's equilikely. The technical term is equilikely. Chances, so what is the likelihood? So if it's the chances of the ceiling fan falling down and not falling are not the same, right? So it cannot be half, right? So whenever I'm calculating the probability, if I roll a dice, what is the probability that I roll a 2, right? Here I can divide, the total cases are 6, because in a fair dice, all these cases had equal chances, right? It's equilikely. Is this clear? Any questions? Guys, any questions on this? Ceiling fan is not similar to tossing a coin, right? Because in a ceiling fan, the cases are not equilikely, right? Why am I assuming that both the events are not equilikely? Either it will fall or it will not. Have you ever seen a ceiling fan falling down? Right? I mean, if it were equilikely, then the probability would have been half, and every second day you might have seen a ceiling fan falling down, right? So it's right. So that's the point. I hope it is clear. Yeah, so with this information, we cannot calculate the probability of the ceiling fan falling down. Okay? All right. All right. Coming to joint events, calculating the probability of two events happening together, right? Or, either event A happening or event B happening. So there are a couple of rules when we need to calculate the probability of joint events. If the events are independent of each other, independent, right? What is the probability that Trump will, revoke the sanctions on Iran, and the probability that it will rain tomorrow in New Delhi? They're independent, right? They are, I mean, one will not have any effect whatsoever on the other, right? So if I need to calculate the probability of both these events happening together, so what is the probability that it will rain tomorrow and Mr. Trump will revoke the sanctions on Iran, right? I can just multiply the probability and I can get the joint probability, because these events are independent. Independent are events, are those events which don't affect each other in any way, right? Is this clear? Guys, is independence of events clear, right? One event is in no way affecting the other and vice versa. So if that is the case, then I can simply multiply the probability and I will know the probability of the events happening together. By the way, this, if you look at the slide, A and this U, B is read as A or P, and both events happening together, A and B, is represented as A inverted UB, right? So this is it is called as A and B happening together, right? A intersection B. This inverted U is basically the intersection. This U is union. So A or B happening, right? Right? So independent occurrence of A does not affect the probability of B. I can just multiply the probabilities of independent events to get the probability of them happening together. Addition rule is for events, if I want to know either A will happen or B will happen, right? Either, so if I roll a dice, what is the probability that I will get a 5 or a 6, right? So right? Or 5 or 6, right? So in the addition rule, PA union B, I need to calculate the probability of A plus probability of B minus the probability of both of them happening together. Why is this? Because so, back to our 10th grade high school Venn diagrams, if you remember. So this blue circle is, say, event A, right? And this white circle is event B, right? So if I need to calculate either A or B will happen, I need to calculate the probability of both these events, right? So A plus B. But if I do a plus, then I have actually added this shaded area twice, right? Once when I was calculating the probability of A, second time when I was calculating the probability of B. So I've added this shaded area twice. So I need to subtract it once. So probability of A or B happening is probability of A plus probability of B minus probability of A and B happening together, right? Is this clear? Independence does not mean mutually exclusive. Mutually exclusive is that they don't share a shaded area for that matter. If I know if A will happen, then B will not happen, right? Those are mutually exclusive, right? Okay. Any questions on A or B happening or A and B? I have a couple of examples for you guys so that you have a better understanding. Simple examples. So say I'm rolling a dice, right? I'm rolling a dice once, right? And it's a fair dice, right? So all the cases are equally likely. And I define two events, right? So event A is probability that an even number will show up, right? An even number will show up. And event B is probability that either a 3 or a 6 will show up. So I roll a fair dice once, and I want to know what is the probability of A and what is the probability of B, right? So what is the probability of A? Guys, 1 by 3? 1 by 3, is it? 1 by 2, my friend. Hey guys, what are you doing? Probability of A would be 3 by 6, is half. So it should be half, guys, not 1 by 3. Hey dude, even number shows up, 2, a 4 or a 6. So there are 3 cases divided by 6, so 3 by 6 is half, right? Probability, you can have it percentage, you can have it in point, it doesn't matter. So 0.5 or 50% is the same thing. What is the probability of B? Probability of B, 1 by 3. Yeah, 1 by 3, so everybody is clear with this. Great. What is the probability that A or B will happen? Either A or B will happen. So what is the probability that A and B can happen? A and B will only happen if I roll a 6, right? If I roll a 6, then A and B will happen because I've rolled an even number and I've rolled a 3 or a 6, so I've rolled 6. So if I roll a 6, A and B will happen. So the probability of A or B happening, I know the probability of A, I know the probability of B, and I know the probability of A and B happening, which is 1 by 6, because the only case where A and B will happen is if I roll a 6 and the probability of rolling a 6 is 1 by 6. Is this clear? Anybody who did not understand this? There's a question, if the events are not equally likely, then how do I assign a weightage? I need to, so, it's like saying that if I'm tossing a coin, but it is unfair, right? If I roll it 3 times, 2 times it will show a heads and 1 time it will show a tails. So I need to add all these things. So there are 3 cases because now for every 3 tosses, 2 will be heads, 1 will be tails. So I need to count all the cases in which the bias is there. So the probability of getting a tail in such a coin would be 1 by 3 and getting a head is 2 by 3. All right? Can we use probability of A to calculate A and B? Can we multiply the probabilities? No, we cannot. They are not independent, right? This is important. They are not independent. If A happens, I know something about B, right? The numbers are coming out this way that, it doesn't matter in this case. But remember, if event A can give me some information about event B, then they are not independent, right? So if event B was probability that 2 or 4 shows up, then event A is telling me a lot of things about event B, right? So they are not independent, right? All right. So is this clear? So this example is clear. So everybody got 2 by 3. Yeah. So this is simple stuff. So remember, I'll just increase the level slowly. Independent events. Now I am tossing a coin twice. Tossing a coin twice. Event A is that in the first toss, head shows up. Shows up in the second toss, right? So what is the probability that head shows up in the first? So I'm tossing the coin twice. Event A is that head shows up in the first toss. Event B is probability that tails shows up in the second toss, right? So both A and B happening together, half into half, because now they are independent. First toss will have absolutely no bearing on the second toss, right? A into B. Are you guys aware of a roulette table in casinos? If you've ever been to a casino, right? There's a spinning wheel with around 36 numbers, right? And you can bet on those numbers, and if you bet, you can bet on an even number, you can bet on an odd number. Yeah, you are aware of roulette. So I mean, just to give you an actual thing that happened with me, right? So I don't remember I was in Holland Casino. There's a casino in Amsterdam, Holland Casino. Yeah. So roulette table, they spin the wheel, and there's a ball, and whatever number the ball lands on, if you bet on that number, then you win, right? So something like that, right? So it's a gambling thing. So, what had happened, so people were betting on odd and even, right? So what had happened, for 7 consecutive times, the ball had landed on an even number, right? So I was just observing, and in the 8th round, so the 7 consecutive times that the ball had landed on an odd number, right? So say, I don't exactly remember whether it was an even or an odd. So say 7 consecutive times the ball had landed on an odd number. So on the 8th time, nobody wanted to bet on odd, right? And everybody betted on an even number. And just for fun, because I knew that these rolls, these spins are independent of each other, right? Even if 7 times consecutively the wheel has, the ball has landed on an odd, that has no bearing on the next round, right? So just for fun, I bet on an odd number. And funnily, I mean, it was so funny at the time. There were loads of chips on even, like, and there was once, 2-3 chips, small little stack of my chips on the odd. And it just so happened that again the ball landed on an odd, and I mean it was pure luck, right? I mean, it was just 50-50. It could have been odd, it could have been even. But the point was, it would have, people were thinking that because 7 times consecutively the ball had landed on an odd, now it will land on an even. And, I just for fun, I bet on odd, and just by chance I won. But it was a good example that, keep emotions out and understand your probability, right? All right. Okay. There are a couple of questions. So I mean, independent is union and independent is intersection. No, guys. Hey, dude. No, I absolutely don't mean that. Union, I said, is probability of event A or B happening, or B. It has nothing to do with independent or dependent, right? It's simply read as event A or B happening, right? Union. Intersection is A and B happening, right? So simple in English terms, what is the probability of A or B happening would be represented as A union B. What is the probability of A and B happening together is A intersection B. The way you calculate them is different, obviously. If they are independent events, then I can simply multiply the probabilities to find out A and B happening together. If they're not independent, then I have to do something else, right? And I'll tell you what you have to do, right? But if they're independent, then it's very simple to calculate the probability for A intersection B. For A or B, I've told you this simple formula, so you can calculate it right through this. So they are not, or and have nothing to do with independent, to say, right? If I need to calculate the probability of A and B and they are independent, then I can just multiply the probabilities, right? Is this clear? Guys, is this clear? What is the physical interpretation of multiplying probability of A and B? This is a good question, and I'll have to get into the absolute basics of probability and counting. I'm just wondering if I have enough time to tell you that. So, it's because of permutations and combinations, right? If two events are independent and I need to know the total combinations of these two events, then I can simply multiply them. It's as simple as that, right? So it's like if there are 2 apples and 3 oranges, right? And I need to see this is not a good example actually. If there are think about it this way. If there are 2 events, right? One event has 5 cases and the second event has, say, 2 cases, right? What are the total combinations of these events, right? There will be 10 combinations where event A and event 1 and event 2, right? So 5 of event 1 into number of cases of event 2, right? So you can multiply to form the combination, and because of these combinations, because I can multiply to get these combinations, you actually eventually multiply to find the probability. But let me not get into that. If you are confused, I can help you with it offline, right? So it's because of combination. That's what I can tell you, right? Addition rule is always valid. Product rule is valid only for independent events. That is absolutely correct. There's a question about, but based on formula, it's 1/6 into 1/6. What do you mean? So they're not independent, right? Mani, they're not independent, right? So, Mani, I don't know which example you're talking about. If you can just tell me which example, and then I'll be able to explain it to you. So I'm assuming that everybody is clear with addition rule, multiplication, independent events. Yes or no? Was any question missed? Manish, you can repeat your question. I don't know which example you're talking about. So it will be great if you can repeat your example. Dude, no, no, that is, so one of you guys is saying that is independent means addition and dependent means multiplication. That is exactly what I was saying, that this is not what I mean, guys. So, okay, I guess you guys would find this Excel helpful. So, okay. So let me just draw a table for you guys, and hopefully that will make it easier, right? So don't worry, this is a simple thing. So events probability, right? So there can be two sort of events, dependent or independent, right? So addition is basically A or B, right? And intersection is A and B, right? Right. So, all right. So this is how it is. If events are independent or dependent, probability of A or B will always be P of A plus P of A plus P of B minus P of A and B. All right. So independent of, is this clear? All right. So this is addition, right? This is, I'll have to count cases. This would be probability of A and B can be given by probability of A into probability of B. Is this clear now? Guys, is this clear? Krishna, is it clear? So, okay, so Manish was given an example. Manish, the example that you're giving, they're not independent, so you cannot multiply. Right? They're not independent. So one of you guys have asked me to give an example of dependent and independent events. Independent event would be, I gave you an example, right? Mr. Trump revoking the sanctions on Iran and it raining tomorrow in your city. Right? They're independent events. One event has no bearing on the second event. Right? Dependent events would be dependent events. Example would be A is I roll an even number on a dice. Event B is I roll a 2 or a 4. Right? If I roll, the case is I'm rolling the dice once. Are events A and event B dependent? Yes, they are dependent. If I know anything about event A, then I know a lot of things about event B, right? And if I know about event B, I know things about event A. So they're sort of dependent, right? I know A will give me information about B. Is this clear? Example of count cases I will give you, but is this clear? So everybody understands this table? Yeah? So let me just save this. All right. All right, so everybody is clear, so let me just move forward, right? Yeah, and Andrew, thank you, but I think now it's clear. If so I'll move ahead. But yeah, you're right. That's a good way of showing. So now, coming back to conditional probability, not back to actually. Now it's a. I'm sorry. It's so now coming to conditional probability, right? And don't worry, I will tell you the example of counting cases, right? I have an example in my slide, so I will show you that. All right? Okay. This is conditional probability. If A has happened, probability that B will happen. Right? Probability of an event given that event 2 has happened. Conditional probability, very important. We use Bayes' theorem to calculate this. Again, one of the most crucial theorems in the world of probability. Bayes' theorem, heavily used in options theory, heavily used. Options pricing cannot be done without Bayes' theorem. Right? Very important. So this is the beginning of. I'll tell you. I'll familiarize you guys with Bayes' theorem. Right? All right. Conditional event, occurrence of an event given that some other event has occurred. Mind you, this is one of my favorite things. Right? I love Bayes' theorem, and it's very important for you guys to understand this. Right? Denoted by probability of A pipe B, right? A and that line B, read as probability of A given that B has already occurred. The formula is very simple. Probability of A given B is probability of A and B happening together divided by probability of B. This is the whole concept of Bayes' theorem. Right? This is the whole formula. First a simple example, then an example from the financial world. All right. Probability, I roll a dice once. Probability that 5 shows up. Right? A is probability that 5 shows up. B is probability that an even number shows up. Right? What is the probability of A? Oh, sorry. This is, yeah, okay, so this is. I shouldn't have saved it. But anyways. Probability that 5, or you know what, let me just change, or this is fine, and then I'll give you another simple example. Probability that 5 shows up, probability that an even number shows up. 2, 4, or 6. What is the probability of A given that B has already occurred? So probability that, what is the probability of A given that B has occurred? Shouldn't it be 0? If I know that an even number has shown up, I know that A can never happen. Right? So it's 0, right? So what is the probability of A and B happening together? It's simply 0, right? If a 5 has shown up, then an even number cannot show up. If an even number has shown up, then a 5 cannot show up, right? So I'm rolling the dice once, a fair dice once. Event A is 5 shows up, event B is an even number shows up, right? Probability of B is 1 by 2. So is this clear, guys? So A given B would be 0. If B has occurred, if an even number has occurred, I know that either a 2, a 4, or a 6 has occurred. I know for sure that 5 has definitely not occurred. So it would be 0. Is this clear? Any questions on this? Any questions on this? And let me just change this example to this, what will happen? If I change the example, one doubt, yes, tell me. These are not independent events, I agree. I agree that these are not independent events. I absolutely agree. And that is why I did not multiply these probabilities, right? The probability of A was 1 by 6, probability of B was half. But probability of A and B is not 1 by 12. I'm not multiplying them, right? It's simply 0 because A and B cannot happen together. So I just simply counted the cases, right? What are the cases where A and B will happen together? No cases. If A will happen, I know for sure B will not happen. And if B will happen, I know for sure A will not happen. We are only rolling the dice once. In the example, we are rolling the dice once. So please pay attention, right? I'm not rolling it twice or thrice or whatever. I'm rolling the dice once and I am defining my events as event A is rolling a 5, event B is rolling an even number. Is this clear? No, even in my previous example, I was only rolling it once, guys. Only in that toss, the example when I was tossing the coin, I was tossing it twice. In this also, I was rolling a dice once, right? All right, Manish? Yeah, that is why I never said you can multiply. I never said you cannot multiply in these cases. If you are rolling a dice once, you cannot multiply. That is what I told you, that the numbers are such that it's just by chance that if you could multiply, you are getting the same number. But you cannot actually multiply, right? It's by chance that it has come as 1 by 6. I never multiplied them, right? In this case, I multiplied. I should probably change that example. Anyways. So, okay. So, probability that 2 shows up. Now, okay. Different question. If I'm rolling the dice once, only once, event A is 2 will show up. Event B is an even number shows up. Now, this would be interesting. What is probability of A and B happening together? What is the probability of A and B happening together? Yeah. Or, let me just change this example. Probability that either a 2 or a 4 shows up. So let me just change this example because this will sort of not create any doubt. Now, what is the probability that A and B will happen together? A and B. It's 1 by 6, right? This is 1 by 6, guys. This would be 1 by 6, right? Is this clear? Because A and B will happen together only if A happens, right? Only if A happens, right? So this is 1 by 6. B is half, is 1 by 3 in this case, right? So this would be half, right? Is this clear, guys? Anybody who did not understand this? How did we get 1 by 6? We got 1 by 6 because A and B will happen together only if I roll a 2, right? That is the only case where A and B are happening together, right? Right? So I just changed the question a little bit. So please re-familiarize yourself with the question. Event A is probability that 2 shows up. Event B is either a 2 or a 4 shows up. Right? What is the probability that A will happen given B will happen? So A and B happening together would be 1 by 6, because the only case in which both these events will happen is if I roll a 2. And what is the probability of rolling a 2? 1 by 6. Clear? So, and probability of B is 1 by 3, right? So, is this clear, guys? Any questions? Any questions on this? Anybody who did not understand how I got half? Anybody who did not understand how I got half? And also, come to think about it. If I know that either a 2 or a 4 have been rolled, right? What is the probability that a 2 has been rolled? It's half. Because one case where 2 is rolled up, given that either a 2 or a 4, so divided by 2, so it's half, right? Yogi Raj, what are you not getting? How did we get 6? Okay, so 1 by 3 should be very clear, right? 1 by 3 should be very clear, Yogi Raj. What is the probability that a 2 or a 4 shows up? 2 cases divided by 6, 1 by 3, right? Is that clear? Yes or no? How did I get 1 by 6? A and B will happen. A and B. A and B will only happen if I roll a 2, right? A and B will only happen if I roll a 2. Right? Because event A will get satisfied if I roll a 2. Event B will also get satisfied if I roll a 2. There is no other case in which both events A and B will be satisfied. So if I roll a 2, then A and B will happen. What is the probability that I roll a 2? 1 by 6. Is it clear? Should I move on? Alright, perfect. So every doubt clear. You already know this. Let me move on. Please ignore this slide. I would urge you to ignore this slide. I hate this slide. These are different definitions of the same thing. I have never used this, and I have cracked each and every problem of Bayes theorem. In Hindi we call it the Ramban. In English it's the I don't know the English form of it. I always forget. Some arrow, I don't know. But it's the point is that it's it's the ultimate portion, right? I mean, this Bayes theorem, this first formula, A given B is probability of A and B divided by probability of B. You can crack any Bayes theorem problem with this formula. You don't need to look at anything else. All right? Perfect. All right. Now I have a question from the financial world where I will tell you how to count cases and whatnot. So it's I find it a good example to sort of introduce you to the concept of Bayes theorem and counting cases and whatnot, right? Silver arrow or something. Anyways, so we have this data from 2,000 samples, right? 2,000 days where two things happened. Either the index price decreased or increased. So, we had a sample of 2,000 days. These are fudged up numbers, right? So please don't rely on these numbers, but people do this sort of an analysis. So it's only the numbers are fudged up, but the analysis is correct, right? So we have 2,000 data points, and we observed two things: whether the index price increased or decreased in those 2,000 days, and we also noted the interest rates, whether the interest rates were declined, were decreased or increased, right? How do I read this table? So there are total 2,000 cases, right? If I look horizontally, index price declined in 1150 cases, right? And in 850 cases it increased, right? So total of 2,000. Is this clear? Can you read that index price declined for 1150 cases and it increased for 850 cases? I am assuming that there was never a case when the index was absolutely flat. Even if it increased by 0.1%, we will keep it as an increase, right? So there was no case where it was absolutely flat, right? All right. Decrease. So if I read vertically, then interest rates decreased 1,000 for 1,000 days and they increased for 1,000 days, right? So total of 2,000. Index price decline is when the index price decrease, right? So starting of the day, if it was at 100, end of the day it was below 100, right? So it declined. Index price increased as starting of the day was 100, end of the day it was above 100. So it increased. As simple as that, right? So if I look at vertically, then interest rate decrease for 1,000 days, increase for 1,000 days, right? And then we have this quadrant, these four figures in between. So how do I read this? So there were 300 days when the index price decreased and the interest rates decreased, right? Charles, in a minute, I will tell you. So index price, so this 300 is both the interest rate and the index price decreased. This 850 is when the index price declined but the interest rates increased, right? And then similarly this 700 is index price increased but the interest rates decreased. And this 150 is when both these increased. Is the table clear? Yes or no? Is the table clear? Anybody who did not understand the table? Okay, everybody is clear with the table. Great. Event A is probability of index price decreasing. Event B is probability of interest rate increasing. What is the probability of A given that interest rate have increased, given that B has occurred? So essentially I want to find out what is the probability that index price will decrease if the interest rate has increased. Anybody who can answer this? So is the question clear? Is the question clear? No, the question is not clear. Why is the question not clear? So the question is, so Nathan, you understood the table? Yes or no? So now, event A is probability that index price will decrease. Event B is probability that interest rate will increase. So I'm defining these events in this way. Now my simple question is, what is the probability of A given that B has occurred? So I hope the question is clear. What is the probability of, so probability of A given B is A and B happening together divided by probability of B. So let us first calculate the probability of B. What is the probability of B? What is the probability that interest rate will increase? Half, right? Half, as simple as that. 1,000 cases where it will increase, total samples 2,000, so it's half. What is the probability that A and B will happen? So what is the probability that index price will decrease and interest rates will increase? Interest rates will increase, so I'm looking at this 850 number, right? 850 by 2,000. Index price is decreasing and interest rate is increasing. So 850 out of 2,000, right? So this is 850 by, why it is not, why probability of B is half and not 150 by 1000? No, dude, probability of interest rate increasing, right? Independent of what happens to the index price, right? When I'm calculating the probability of B, I really don't care about the probability of A, right? So probability of B is, so there are two cases in B. 1000 cases in which it increased, 1000 cases in which it decreased. So probability of B is 1000 by 2000, as simple as that. This was 1000 by, so it is 85%. Bayes theorem tells me that if the index, if the interest rate has been increased, there's an 85% chance that the index price will decrease. In monetary policies, on days when the monetary policy is announced, if you can figure out this data, you can use Bayes theorem to calculate this number. You immediately know what the monetary, as soon as the monetary policy is out, you can take a position on the index, right? Based on these numbers. If the interest rate has decreased, then whether the index price will increase or not, or vice versa. So this is how you can use Bayes theorem, very simple, real world, right? Yeah, so you can assume that these 2000 samples are for 2000, for basically days where the interest rates were either decreased or increased, right? So we are only noting out those days when the interest rates were changed. There's a question, what is Bayes theorem? What do you mean? Dude, Bayes theorem is this, that A given B can be calculated by probability of A and B divided by probability of B. This is Bayes theorem. So this formula is basically the Bayes theorem, right? Conditional, the way to calculate conditional probability is Bayes theorem, right? Can I explain A and B? Yes, I can do that. No problem. Where do we get this data from? From your vendor, or you'll have to do a, we can discuss, getting data is a different problem, so let us discuss it offline, but the concept should be clear. Let me discuss why probability of A and B is 850 by 2000. So if you look at this table, there are 850 cases in which the index price declined and the interest rates increased. So Alejandro, is the table clear? If the table is clear, then you would appreciate the fact that there are 300 days where both the interest rate decreased and the index price declined. And there are 850 cases in which the interest rates increased but the index price declined. And we need to calculate this part. We need to know about this part, right? When the interest rates increased and the index price declined. So there are 850 days out of 2000 when this has happened. So probability of A and B is 850 divided by 2000, right? Can we use the formula of independent events? No, we cannot. They're not independent. They're not independent. Interest rates changing have an effect on index price decreasing or increasing, right? So please don't use the independent formula. By the way, you would appreciate the fact, so P of A given B is P of A and B divided by P of B. If A and B are independent, then P of A and B is equal to P of A into P of B. If I put this formula here, then P of A and B is P of A into P of B. This P of B will cancel, so then this would be for independent events, which makes sense, right? Because A has no effect, B has no effect on A, right? So A given B will be probability of A because frankly B does not affect A, right? So this is clear. So everybody is clear with this example? Bayes theorem is clear. Shall we move forward? Yes or no? Anybody who did not understand? Perfect. Perfect. I will wait for a minute and then I'll move forward. Couple of people have asked me to wait. Yeah. I'm here too. Which Excel? This Excel? Yeah. All right. So I hope this is clear. So this would be clear. Please repeat the Bayes formula. Okay. So let me then do this also. For dependent events, it would be this. For independence event, it would be this. All right. So this should be clear. All right. If they're dependent, then it is this. It's as simple as that. All right. This is the question. In this case, how to populate the value in this sample is smaller. Hence, it is easier. But what is the samples are bigger? You can write program to calculate it, right? I mean, you don't have to do it manually. You can collate the data and then use a very simple. You can do it in Excel also, right? To sort of populate this data. But if the concept is clear, then let me move forward because concept is more important, right? Getting the data, collating it is a different thing altogether. K5, is it dependent or independent? This is the usual Bayes theorem. So right, so this is the usual Bayes theorem. If A and B are independent, then this happens. So, right, so what do you mean? So okay, is this all right now? So this is for any dependent or independent. But then because for independent, I can substitute A and B as PA into PB. So this becomes this, right? Is this clear now? Any questions? All right. So let me move forward. Oh my God. All right. Okay. Fair value of gain. Expected value. Expected value is simply the probability multiplied by the value of that quantity. So let me give you an example of explain you this concept with an example, and then I will go back to my slide. Say we have a stock, right? Trading at $100. As simple as that, right? Stock price is $100, right? This is 1st January 2018, right? Now, somehow, let us not go how I calculated the probabilities, but somehow I calculated the probabilities that 31st December 2018, I calculated the price and its probability. right? So this is the price and this is the probability. So the price on 31st of December, the probability is 0.25. For it to end at 120, or better still, let me put this way, $80, $100 is 0.3, $110, or this can be say 90, right? 110, it is 0.4, and $120, it is 0.05, right? So I have on 31st of December, this is the stock can have these 4 prices with these probabilities. The question is, what is the expected price of the stock on 31st December? This is the question, right? So this is the question. Is the question clear? My stock price on 1st of January 2018 was 100. Somehow I calculated the probability scenario for 31st December, right? There's a 25% probability that the stock will end at 80 on 31st of December. There's a 30% probability that it will end at 90, 40% probability that it will end at 110, and 5% probability that it will end at 120. Now, what is the expected price of the stock on 31st December? Is it clear? Is the question clear? The simple answer is so this is how we calculate the expected value. Expected value is simply the sum product of price into probability. So, or in other words, it is equal to 80 into 0.25 plus 90 into 0.3 plus 110 into 0.4 plus 120 into 0.05. Is this clear? So this is the expected value. This is how I calculate the expected value. Clear? Yes or no? So this is the, according to me, this is the fair price of this stock on 31st of December. All right? So this is the expected value or the fair price of this stock on 31st. Fair price or expected value. Is this clear? Should I move ahead? Yeah? Great. Will we learn in future about how to calculate the probability of stock? I will give you a very brief idea today only, but a very, very primitive model of stock price movement. Very primitive, right? But we'll do it today, right? Okay. So I'm hoping everything is clear so far, right? So let me give you another example of expected value. Five or six. So there's a game where I'm rolling the dice. It's a very simple game. I'm rolling a dice. If a 5 or a 6 show up, then my payout is $100. Right? Payout is 100 means. So if I'm paying say X amount of dollars to play this game, and I roll a 5 or a 6, I get my money back, those X dollars plus $100 more. Right? plus $100 more. So my payout is 100 if I roll a 5 or a 6. My payout is 0 if I roll any other number. So I lose my X dollars. The money that I gave to play this game, I lose that money, right? And if I win, I get those X dollars back and an extra $100. So my winnings are $100, right? Question is, what is the fair value of this game? How much money will you shell out of your pockets to play this game? Is the question clear? Some people are saying 40, some people are saying 60. I don't know what's the real answer. No, is the question clear? Guys, is the question clear? Yes or no? Some people are saying 33.33. Yes, everybody is saying now 33.33. None of you guys have got the answer correctly. Or is it 33.3? I don't know. I'll have to calculate. So how do we do it? What are my expected winnings? What are my expected winnings? Expected value of my winnings. Expected value of my winnings would be probability of my winning multiplied by the amount that I win. Yes or no? So this is the question, right? Initial investment is the question. What is the money that I can pay to play this game? What is the expected winning? What is the probability of me winning? What is the probability that I will win? 2 by 6. So my expected winnings is, you're right, 33.33. Very nice. What is my probability that I will lose? How much do I lose when I lose? If I'm paying X amount, I lose 2 by 3 times. So 2 by 3 into X is my probability is my expected loss. My winnings should be greater than my loss. 1 by 3 should be 1 by 3 into 100 should be greater than 2 by 3 into 100, or X should be less than $50. So if somebody is letting me play this game for $49, I will play it happily. Is this clear? Yes or no? What needs to be? You are not paying attention. That is why you need explanation. No, I'm just kidding. No, guys, please pay attention, right? So, expected winning is what? 100 divided by 3. You know this, right? You only said that this is the answer. You guys were like, yes, we know. What did I do? Oh my God. Expected winning, expected losses, 2 divided by 3 into X, because I'm losing X amount of money. My winnings should be greater than losses, which means 100 by 3 should be greater than 2 by 3 into X. Solve this equation and you will get X should be less than 50. All right? So if you are paying more than $50 to play this game, more or less you will lose. I mean, you will lose money. You did not understand this problem. What did you not understand? What did you not understand? Tell me. Was the question not clear? Or is the solution not clear? Yes, for both. Oh my God. So when, guys, when I'm asking the question and when I told you that, is the question clear, then you should let me know that the question is clear or not. Right? That's fine. That's fine. Frankly, I can repeat it 100 times. I don't care. But, it will be best for all of you if you are paying attention and you tell me there and then. But that's fine. So I'll just repeat the whole thing again. That's fine. So, the question is, I'm rolling a dice, right? I'm rolling a dice. Okay, so let me just Say that again. So there's a game where I need to pay X amount of dollars to play this game, right? And the game is very simple. If I roll a 5 or a 6, right? I'm rolling a dice and a 5 or a 6 show up, then I get my X dollars back, the one that I paid to play this game, and I get an extra $100, right? So I win $100. Right? My total winnings is $100. However, if I roll a 1, a 2, a 3, or a 4, any number other than 5 or a 6, I lose my X dollars. As simple as that. So then, how much money can I pay to play this game? This is the question. Is the question clear? Yes, if I'm... Is the question clear, Sumit? There's a question, why is winning not X plus $100? So if you went to play this game with $1,000 and you came back with $1,100, and somebody asks you what were your winnings, was your winning $1,100 or was your winning $100? So your winning is $100. So was the question clear? All right, great. Now I need to calculate this X. So how do I calculate this X? What is my expected winning? Expected value, as I said, was amount into probability of that amount. Amount when you win. So what is the expected winning? Expected value of winning? Amount when you win is $100. Probability of you winning is 1 by 3, because the probability of you rolling a 5 or a 6 is 1 by 3. So your expected amount of winning is 33.33. 100 divided by 3. 100 into 1 by 3. Your losses, what is the expected value of your losses? Your probability of losing is 2 by 3. And if you lose X amount of dollars, the amount that you paid to play this game. So your expected value of losses is 2 by 3 into X. Now obviously you want your winnings to be greater than your losses. So 100 divided by 3 should be greater than 2 by 3 into X. Solve for this equation, you will get X should be less than $50. Is it clear, guys? Yes or no? Everybody is clear with this example? Great. And I don't know. Now I'm feeling I might have sounded a bit harsh when some people were asking questions, but don't get me wrong. I mean, frankly, the more questions, the merrier. It's just that I should know that you are not asking questions out of context, because that just takes up time. And I know if you've paid attention, be true to yourself, right? You've paid attention, and you still have a question. That's fine. I can repeat it 10 times, but just make sure that you are paying attention, right? All right. Time for a break. Yes. All right. We'll have time for a break. So it is, but today I will have a short break because this is a big lecture. So, okay. So what's the time? Yes, it's 5:38. Oh my God, 5:43. We will reconvene at 5:50. All right? 5:50. All right? I'm still here. If you have any questions, please feel free to ask them. I'll be more than happy to answer. All right? Seven minutes break. Reconvene at 5:50. So, no, Rishabh, I've told you, right? I mean, I think I've repeated it now 3-4 times in my lecture. VWAP, I told you what VWAP is in the last lecture, and in my lecture on trading systems, I will cover RSI and a strategy on VWAP, right? So don't be worried, right? All right. VLOOKUP also I'll get it. I'll get to it. Trading systems, VLOOKUP is like a 1 or a 2 minute thing, so don't worry about it. But yeah, RSI is important and VWAP. So the VWAP strategy I've already, I always cover it in my trading systems lecture, so don't worry about it. RSI is also, it will be best if I cover it there, because I will be sort of discussing the finer points in a trading system. So when I cover that, there's a strategy on EMA. I'll cover RSI there. All right. Yes, X should be less than $50. Isn't the Bayes theorem formula probability of A given B is probability of B given A into probability of A divided by probability of B? So that's what, there are a lot of people who define Bayes theorem in different ways. Yes, the actual thing is what you have said, but the formula that I told you about and the formula that you are telling, they are pretty much the same, right? I mean, they're interchangeable, right? It's like saying that 4 into 3 is 12, or I can simply add 4 3 times, right? Whatever suits your need, right? So it's basically the same thing. And I've always cracked each and every problem of conditional probability through that formula. And, I feel very comfortable with that formula. And basically, you can convert that formula into 10 different ways. So, we should understand the basic root and then don't worry about the rest. All right? Will we implement the blended pegging of discretion in Python itself? I am not sure if you'll take, so, there, obviously there'll be a lecture on languages, right? So you learn certain languages, I think on C++ or something. I don't know the exact language that you'll be learning. But if you can learn one language, then implementing any algorithm in that language should be simple. In and if you know the logic, you are familiar with one language, you can easily shift to other languages, right? So, I mean, I studied C++ first, and I could easily pick up Python or R or V very easily, right? So that's pretty easy. Bayes theorem, expected values in a strategy. So I told you, right, that strategy for index interest rates declining and index price, it sounds very simple, but this is a very, a sort of introduction of a strategy, right? I mean, then you can add a couple more indicators and you can have a strategy just based on that. Bayes theorem is used in option pricing tremendously, and in your lectures on option pricing, you will sort of figure it out yourself. Options are priced on the basis of Bayes theorem, right? So you'll have a lot of applications of Bayes theorem there, right? All right, so what's the time? So a couple of minutes more. All right. And how can we incorporate more than one dependent variable in these calculations? What do you mean? What do you mean more than one dependent variables? So in these addition rules and what, you can actually just Google them. If A or B or C is happening, then there are very set formulas for more than two variables, right? So we've already talked about more than one dependent variable, right? So there are, and there are Bayes theorem for A given B given C and whatnot, right? I don't want to complicate things right away. So, these are the simplest examples. But if you ever find a problem where you have more variables, then obviously you can. There are very set formulas, and once this is clear, other things will follow easily. Some strategy that we can make. Patience, my friend, patience. In EPAT course, you will be taught a couple of strategies that you can use live. So don't worry about that. How I got 50? My friend, so what is not clear? Okay, so is the expected value of winning clear? Expected value of winning clear, yes or no? Akshay? Expected losses clear? Expected loss clear? Then you just have to solve this equation, my friend. Solve this equation and you will get it. Solve the equation in yellow. You solve this equation, and you will get it, right? X should be less than 50. You just have to solve this equation. So when you are at home, when you have some leisure time, just feel free to solve this equation and you should be there. All right, so it's time, right? So this is a big lecture, so let me not waste any time. Right? All right. So basic statistics again. All right? So we are reconvening. Basic statistics again. Okay. Mean of some data points. Mean is also known as the average, the arithmetic mean, right? The average. You take sum of the values divided, simple ninth grade class. Median divides the distribution into two halves. Range is the difference between the largest and the smallest. Standard deviation is important, right? Standard deviation is the measure of spread of the data from the mean. How spread is the data, right? How far is the data from the mean, right? It is a degree of scatter of data around mean, right? Variance is just the square of standard deviation, right? And as I said, these are used to summarize the data from whatever sample population. In the financial world, and this is important, mean returns is the measure of expected return, and deviation or variance is the measure of risk. How scattered your returns are from the mean returns is a measure of risk. So mean and variance of two variables. So this is very confusing. So to avoid any confusion, what I have is, where did it go? Okay. Okay. Okay, yes. Very good. Can you see the Excel? Yeah? See the Excel? Guys? All right, great. All right. So I have two stocks, Microsoft and Google, right? And I have their returns, yearly returns for 5 years, right? So year 1, Microsoft had a return of 8%, year 2, 1%, year 3, 15%, and similarly for Google, first year 12%, and fifth year 25%, right? The mean would be average. So what is the average yearly return of Microsoft? So average of B3 to B7. Similarly for Google, right? Average of. Now, so what if I invested, say I had $1,000 to invest, right? If I had $1,000 to invest and I invested $500 in each, right? So I create a portfolio where I buy shares of Microsoft and Google, each worth of $500, right? So I'm basically invested 50% of my wealth in Microsoft and 50% of my wealth in Google, right? What is the return of my portfolio, right? What is the return of my portfolio? So basically I need to calculate the mean of X plus Y, right? So mean of X plus Y is mean of X plus mean of Y. So A of X, mean of A of X plus B of Y is equal to mean of AX plus mean of BY. So basically what I'm doing, what is AX? So 50% multiplied by 10% plus 50% multiplied by 15%, I get my returns on portfolio, right? So this would be my returns on portfolio. Is it clear? Yeah? Okay. Variance is simply the standard deviation square. So variance, I can calculate the standard deviation of returns of Microsoft, standard deviation of returns of Google, right? If I square these up, then it would be the variance, right? As simple as that. Now, what is this covariance? Covariance is simply a measure of how is X moving. There's a question, why am I using n minus 1 instead of n for variance? This is a very good question because, this involves some degree of freedoms. If you guys are interested, what I'll do, to explain this, it will take some time. And frankly, I don't want to spend time on why am I using n minus 1 instead of n. The short answer is because n minus 1 is an unbiased estimator of variance. So I know this is confusing, but this is the actual answer. If you guys are interested, just drop me an email and I will, send you an example of why we use n minus 1 and not n. All right, but you would really never, you'll always use n minus 1, right? So you will never use n. In all cases, just use n minus 1, right? But if you are an academician and you are really interested, just send me an email and I will tell you, right? Okay. Okay. Yeah, Bessel's correction. All right. Yeah, for full population you can use n, but full population hardly you will ever use. I can guarantee you will never use full population, right? What is variance in layman's term? Usually intuitive understanding of variance. I mean, I can tell you the intuitive understanding of standard deviation, right? How scattered is your data from the mean, right? What is the spread on the data, right? If it is like really spread out, then the standard deviation would be high. If all the data is very close to its mean, right, then the standard deviation is low, right? And variance is just the square of standard deviation, right? Yeah, n minus 1 is sample standard deviation. N minus 1 is always the sample standard deviation, and you'll always use sample, right? So always use n minus 1, as simple as that. What is the square root rule? What do you mean by square root rule? I don't know what the square root rule is. It's just variance is the square of standard deviation. That's pretty much it, right? All right. Covariance, right? Covariance is a measure of how X and Y are moving, right? So if X is increasing from its mean and Y is also increasing from its mean, then covariance would be high. So let me just show you this, right? So here, if I have to calculate covariance, right? I basically so I subtract the data point 8% from its mean for Microsoft and for Google. So B3 minus B10, so returns of year 1 minus the mean of returns. For Microsoft, the same for Google, right? Returns of year 1 minus the mean of returns of Google. Multiply this for each data point, right? And then sum it up, right? This is the covariance. What is the intuitive understanding of covariance? If X and Y are moving together from its mean, right? So, for example, this case, right, year 3, the return was 15%. So it is jumping. It has increased from its mean, right? And 21% from Google, right? So in year 3, both these stocks have increased from their means, right? So it will add to the covariance, right? The covariance would be higher because of year 3, right? In this year 2, both of these have decreased from their means, right? So they're sort of moving together, right? So covariance would be high because of year 2. Even in year 1, right? Year 1, 8%. Microsoft has decreased lower from its mean. Google is also lower from its mean. Right? So in these 3 years will increase the covariance, right? Because in these 3 years, they sort of moved together from their means. So if they're moving together from their means, then covariance is positive. If they're moving differently, one is increasing, one is decreasing, then covariance is decreasing, right? Repeat. Year 3, so guys, year 3, Microsoft's returns are greater from its mean, right? And so is Google's return is also greater from its mean, 15%. So year 3 will add to the covariance, right? Is this clear? Is covariance clear? Yes or no? All right. So, and then covariance is divided by n minus 1. Now, covariance is just a number, right? It's an absolute number. I mean, the absolute value of that number does not tell me anything, frankly. Yes, if the number is really huge, then maybe they're moving together, but the value itself is not telling me much. So I sort of need to normalize it, right? So to normalize it, if I divide this covariance by the standard deviation of these two, x and y, right? So this is the covariance, right? Let's forget about this. And if I divide this covariance by the standard deviation of these two, then I get this as the correlation. Now this is a standardized, normalized number. This correlation is a normalized number. If it is 1, this means that both these numbers exactly follow each other, right? If A will increase, B will increase, and vice versa, right? I mean, they're moving together. It does not mean causation. It's not that A is causing B or B is causing A, but they're sort of moving together from their means, right? If it is -1, then I know that if A is increasing, then B is decreasing, and vice versa, right? B is increasing and A is decreasing, right? So it's sort of a normalized number, and if it's it's always between -1 or 1. If it is 0, then they're random, right? A can increase or B can decrease. Is it clear? Is it clear? Yes or no? Is covariance and correlation clear? If this is clear, then so variance was clear, right? Variance was calculated. It's basically the square of standard deviation. But how do I calculate the variance of my portfolio, right? So variance of my portfolio. So this were the returns. This is the fraction invested. What is the variance of my returns, right? So variance of my returns would be calculated by this covariance number, and I will show you with an example, right? And obviously covariance and correlation this is how they are related, right? So correlation is covariance divided by standard deviation of x and standard deviation of y. Right? So let me just give you show you this example. Okay, please pay attention to this, right? Pay attention. So we have $1,000 to allocate between assets A and B. Yeah, so in the primer it says correlation is equal to, so this is exactly what this slide is also saying, right? This rho is the correlation, so correlation is covariance divided by rho x and rho y, right? So it's the same formula, anyways. So this is the question. I have $1,000 to allocate between assets A and B. Yearly, I know the yearly returns, right? They're RA and R, right? The means of these returns is mu A, mu B. The standard deviation on the returns is sigma A, sigma B, and I know the correlation between the returns. It is rho AB, right? if I invest W, which is a fraction of my wealth, to A and 1 minus W to B, then my expected returns is simply W into mu A plus 1 minus W into mu B, right? So this is the formula for the expected returns. W into mu A plus 1 minus W into mu B. Variance of my portfolio, right? Variance of my portfolio is given by this formula. W square sigma square plus 1 minus W square sigma B square plus 2 times W, the multiplication of fractions multiplied by the correlation multiplied by the standard deviation, right? So this is the variance of my portfolio. So this is a simple formula. Let me show you an example for this. Right? So can you guys all see the Excel? Yeah. So the assumption is that I'm investing in State Bank of India and Punjab National Bank. I have $1,000 to invest. How much should I invest in State Bank of India and Punjab National Bank? Right? This is my question. And this is the data that is given to me. Expected return of State Bank of India is 10%. Expected standard deviation of the returns is 6%. PNB is 15%. Standard deviation is 8% of the returns. Their correlation of the returns is 0.6. Right? Right. So my question is, how much should I invest in SBIN and PNB? Right? What fractions should I invest in State Bank of India and Punjab National Bank? Right. So what I do is, I make a table where I vary the weights. I vary the weights of fraction of my investment in State Bank of India and Punjab National Bank. So I start with 0% invested in State Bank of India and everything is invested in Punjab National Bank. And then so this row is 10% invested in State Bank of India and 90% invested in PNB, to finally 100% invested in State Bank of India and 0% in Punjab National Bank. All right? And for all of these fractions, so these are the different, these are the sort of different portfolios that I can create, right? And this is the expected standard deviation and returns on my portfolio. So if I invest everything in Punjab National Bank, obviously my portfolio will exactly mimic the characteristics of Punjab National Bank, right? 15% return and 8% standard deviation. If I invest everything in, so let me just do this. Right, if I invest everything in State Bank of India, then my portfolio will mimic the characteristics of State Bank of India, right? 10% return, 6% standard deviation. So for all these weights, I can calculate the standard deviation and the returns of my portfolio, yes or no? Guys, is this clear? Anybody who did not understand this? Because after this, I will tell you how to sort of tackle this question. This is clear? The returns and standard deviation of the portfolios. What is the formula in the cell? The formula in the cell is simply this: expected returns and expected standard deviation. All right. W is a fraction. W is, so this W is basically this guy. 0, 1 minus W is 1, right? So this is 1, so this is 1 minus weight, right? Is this clear? Great. Now what I do is, I plot these two things. So I plot standard deviation on the x-axis and returns on the y-axis. Right? So I can do this, right? So I have this data, right? I have this data. and I plot it, right? And this is the sort of graph that I get. This blue line is what I get. And very interestingly, what can I observe from this blue line? This blue line simply tells me that there are some fractions in which for the same standard deviation, I can get a higher return. This is very interesting, right? So, for example, this point, if I invest everything in State Bank of India, I get a standard deviation of 6% and a return of 10%. Interestingly, if I invest everything, if I invest 66% in State Bank of India and 34% in Punjab National Bank, I get 6% standard deviation and 11.7% return, right? So standard deviation is sort of the risk, right? For the same risk, I am getting a higher return. This simply means I should never fully invest in State Bank of India. Because for the same risk, I am getting a higher return. Is this clear? Yes or no? Anybody who did not understand this? So this is clear? Yeah? All right. So we would always want to invest in portfolios which are sort of above this red oval, right? Here. We don't want to invest in anything that is inside this red circle, because for the same standard deviation, there's a way of investing where for the same standard deviation I will get higher return. Yes, so these are the contrasting points, right? So I'll repeat this part. So if I could, so I can easily calculate the return and standard deviation. I plot them on a graph, right? X-axis is the standard deviation, Y-axis is the returns. All I'm saying is that there are some data points, some portfolio, these are all different portfolios, right? 80% in SBN, 20% in PNB, 99% in SBN, 1% in PNB. So these are different portfolios. There are certain portfolios for which for the same standard deviation, I'm getting higher returns. So if I invest everything in this one portfolio where I'm investing everything in SBN and nothing in PNB, my portfolio will look like this. My standard deviation would be 6%, return would be 10%. But if I invest 66% in SBN and 34% in PNB, this portfolio tells me that, you know what, this portfolio will give me a return of 11.7% and a risk or standard deviation of 6%. So for the same standard deviation, I am getting higher returns. Right? So for the same standard deviation, if I am getting a higher return, why would I invest in SBN? Kam daamon mein wahi price mila, right? Something like that, right? Is this clear? Yes or no? SBN 100% was 6%, SBN 66% and PNB 34% is also 6%, but with higher returns. Anybody who did not understand this? So this is the capital asset pricing model, right? Do fund managers do this analysis? An investor should definitely do this analysis. And yes, fund managers do use this, right? You would never want to invest in individual stocks, right? You would want to invest in a basket of stocks. Why is this happening? Yes, so this is the capital asset pricing model. Why is this happening? Because there is a correlation between SBN and PNB, right? There's a correlation between these two things, and we are sort of diversifying our investment by investing in both of these. That is why it is happening. Right? So because the correlation is not one, therefore we are diversifying. Right? So it is better to diversify, better to invest in stocks whose correlation is less than 1. You can easily Google the formula if you have more than 2 assets, right? Let me not get there because then it will take time, right? So you can go, it's very simple, but I hope the concept is clear. Yeah? All right. So it's, oh my God, it's 8:15. So we are sort of racing against time, but that's fine. Does Excel have an automated code for this? I don't know. I mean, this is very simple, right? You can easily create these things in Excel. So I will share these Excel with you, so don't worry about it, right? So now you know which portfolios to invest and what sort of portfolios to make, right? Yes, standard deviation is obviously crucial when you are investing and whatnot. All right. So moving ahead. So how odds and probabilities are distributed among the events, right? Okay, yeah. So what is a probability distribution function, right? So by the way, everything is clear. Any question on this? Any question on this capital asset pricing model and whatnot, right? If the correlation is 0, then how would the graph look like? You can do it at home, right? Let us do it at home. I mean, if you are clear with the concept, you can play around with this, right? All right. So I'll share these Excel files with you. Right? All right. So everything is clear. All right. Probability. By the way, we are running like 10-15 minutes late, right? So yeah, just a heads up. All right. What is a probability distribution function? It is basically a graph that tells me how the probabilities are distributed, right? So if I, in very simple terms, if I roll a dice, then a probability distribution function will tell me how is the probability distributed among different events. Right? So this is the probability distribution graph for rolling a dice. Right? So if I roll a 1, it would be 0.15. If I roll a 2, it will be 0.15. If I roll a 3, it will be 0.15. So probability distribution basically tells me the probability for each event. All right? Yeah? Probability distribution is. So this is the probability distribution if I toss a coin 100 times. Right? This is the probability distribution for the number of heads I get if I toss a coin 100 times. Right? So for each number, so what the probability that I will get 50 heads is 0.08, around that number. So no, Ravi, I think you are jumping the gun, right? So I'll take that question. Devendra, I didn't get your question, right? This is yeah, for different events, right? So if I'm rolling a dice, there are 6 events that can happen, right? Either I can roll a 1, a 2, a 3. So for each event that can happen, it gives me a probability, right? Right? So if I'm tossing a coin 100 times, so there are 100 cases, right? If I'm counting the number of heads, then there are 100 cases from 0 to 100, right? So probability distribution will give me a probability for each event, right? So what is the probability that I will get 50 heads, 40 heads, 30 heads, 10 heads? So it will look something like this, right? Right, so this is it, right? So is this clear? Is the probability distribution clear? Yes or no? Guys, yes or no? All right. Now comes, so this I can draw a probability distribution function if the events are quanta. What is if they're not continuous, right? If they are discrete in nature, right? 1, 2, 3. They're not continuous. What would be an example of a continuous function or an event? Returns of a stock. Returns of a stock do not or cannot necessarily take a discrete value, right? They can take any value. So returns of a stock in a year, it can be anything. 10%, 10.2%, pi percent, e%, right? Any number. Root 2%. So it can take any value on the number line, right? Whereas if I'm rolling a dice, there are only fixed number of events that can happen. It's fixed. However, the returns of a stock are sort of continuous. There are infinite number, right? It can take any number on the real number line, right? So in these cases, the sort of events are continuous, right? So when the events are continuous, I cannot really draw a probability distribution, because come to think about it, if somebody asks you what is the probability that the return of a stock will be exactly 10%, it's really zero, right? Exactly 10%, exactly 5.334%. It's pretty much zero, right? I can tell you a range that, okay, the probability of a stock returns of a stock lying between 9% and 10%. That might be a finite number, but exactly 10% would be negligible, right? Because it's sort of that particular number divided by infinite cases. Is this getting clear to you? So when the events are continuous, we use a probability density function. All right? And how do we calculate the probability from the probability density function? So say a range is given to me. What is the probability that the return of a stock will lie between 4% and 5%? So what I do is, if a probability density function is given to me, I just calculate the area under the curve between that range. So between 4 and 5%, I calculate this area, this shaded area, by integration or whatever, and I get the probability that the stock returns will lie between 4 and 5% with this probability. Is this clear? So probability and probability distribution and probability density, both of these tell me the probability of the events. Probability distribution is used when the events are finite in number, right? They're not continuous. They're discrete in nature, right? And probability density is used when the events are continuous. Calculating probability from a probability distribution function is very easy, right? You can just read from the graph. Event and then the probability of it. However, in a probability density, I need to know a range to calculate the probability, right? So I can calculate the probability of the returns of a stock lying between 4 and 5%, right? How do I do it? I just calculate the area under the curve between 4 and 5% in the probability density. I have already given you an example of probability distribution function. Yeah? Yes or no? Density function I'll give you in a minute. Is this clear? Is the difference clear? Is the concept clear? Great. Great. So probability density functions somewhat look like this, and there's a very common probability density function called the normal distribution. It is called the normal distribution, and there are some very peculiar properties of this normal distribution function. What are these characteristics? it is a special type of a probability density function, right? This is a very special type of probability density function. And its speciality is that if I tell you the mean and the standard deviation of this distribution, I can calculate each and every point of this density function. So basically, this probability density function is so special that it can be defined by only two things, the mean and the standard deviation. So if I tell you that, you know what, the returns of a stock are normally distributed. So I'm telling you the density function, right? The probability density function. So it is, say I tell you that, you know what, the returns are normally distributed with a mean of 10% and standard deviation of 15%. Essentially what I am doing is I am telling you that you are now equipped to calculate the probability of the returns of the stock for any range, right? By just using simple maths, you can do it. On y-axis, it is the probability density. X-axis is the variable, right? Returns. Is it related to equipartition? I don't know what an equipartition is, right? So maybe it is, I don't know. This is the probability density. This y-axis, what is the value of this y-axis? It intuitively, don't think about it intuitively, frankly, right? The simple thing is that area under the curve gives me the probability value. So, and there's another. So, is the normal distribution clear? Normal distribution is a special type of a probability density function, which is the whole density function is defined by two variables, mean and variance, and standard deviation, right? And there's a very interesting part to this normal distribution. 68% of the values lie within one standard deviation, right? 95% of the values lie between two standard deviations from the mean, right? 95% of all the values will lie between two standard deviations from the mean. What does this mean? Let me give you an example of what does this mean, right? So, okay. So, you know what? So this is so say these are the average returns of, say, State Bank of India. This is the standard deviation. And say I'm saying that the returns are normally distributed, right? So what does this mean? What does this mean? Right, this would mean that, you know what? First of all, from this standard deviation and mean, I can calculate the probability of returns for any range. And if it is normally distributed, then the probability that the returns of State Bank of India will lie between -5% and 25% is 0.68. This yellow colored cells are very important, and you should know this is the key takeaway from this normal distribution. Very important. Also, are these yellow colored cells clear to you? So this is plus minus one standard deviation. 10% plus minus 15% is one standard deviation, right? 10% plus minus 2 into 15% is two standard deviations, right? So if 95% does not fall within two standard deviations, it is safe to say that it is not normally distributed. Yes, they're actually, it's a one-to-one function. Are these two things clear? Guys, are these two sentences absolutely clear to you? And is it clear that if I tell you that the returns are normally distributed, then you know the probability density function, and by integration of whatever, you can calculate the probability of the returns in any range. Do stock returns typically follow a normal distribution in the real world? No, but it is a great start to model a stock price. Any questions on this? Any questions? Yes or no? All right, then let us move ahead. Do we need to remember these standard deviations? I'm usually against remembering these, but it won't hurt. Just 68 and 95, right? Just two numbers, 68 and 95. Frankly, I get confused, but it won't hurt. All right. So I have taught you all this. What type of distributions do stocks follow in real life? You'll have to calculate that. We can discuss it offline. All right. But frankly, there's no known distribution. Right? Short answer to this is there's no known distribution. All right. So now a model, a very naive model or a very, very beginner's model for stock prices. Right? By the way, we are now 15 minutes late. So anyways. So I will tell you how you can use this after this model, right? All right. So the model is very simple. What we are saying is that today's price is equal to yesterday's price plus a change that is independent of all previous information. So what we are trying to do is we are trying to model the price of a stock, right? And how are we doing that? We are assuming that, the price of a stock today is equal to the yesterday's price plus a change that is independent of all previous information, right? So say we start with some known P naught. So yesterday's price was P naught. So P1 would be P naught plus delta 1. Right, this change. And this delta 1 is independent of P naught and all the previous information, right? Or what we can say is, there's a question, how to plot the graph of normal distribution? You can generate numbers through Excel and whatnot, right? I mean, you cannot actually do it manually. You'll have to generate it through Excel. There's a standard normal distribution function in Excel that can help you do that, right? And it will ask you for a mean and a variance or a standard deviation, and it will do it. All right. All right. So coming back to the model, so price change delta 1 is say K P naught, right? Where K is a random number, right? Because we said that it is independent of all previous information. So K has to be a random number. And interestingly, you can, what you're saying is that this K follows a normal distribution with mean 0 and standard deviation 1. Right? This is the question. If it follows a normal distribution, then it cannot be independent. So it is independent, right? I mean, it is independent of previous information. And it is a random number. It can take any value within that normal distribution. Right? I mean, no matter what happens, no matter the news is good or bad yesterday, it will follow a normal distribution and it can take any number within that normal distribution. So it is sort of independent of all previous information, right? We know, so the question is that, but we know the values of k. So the values of k can be anything, right? It can be from minus infinity to infinity, anything, right? I mean, normal distribution can take any value, right? For that matter, stock returns can also take any value, right? So that does not mean that we know what value it will take. So it is a random number, right? But it will follow normal distribution. So 68% of the times the value of k would be between +1 and -1. But remember, there are infinite numbers between +1 and -1, right? N0 and 1 is a way to represent normal distribution with mean 0 and standard deviation 1. Is this clear? Is delta 1 clear? So we can say that P1 is equal to P0 plus K P0. Or we can say that, you know what? P1 is equal to P0 into 1 plus K, right? All right. Right. So this is how we are defining our model. So P1 is equal to P0 into 1 plus K, right? Is this clear? What is mean? Mean average. Mean is the average, right? I mean, guys, average. So mean is the average. I don't understand. So I just took P0 common, right? So P1 is equal to P0 plus K P0. So you can take P0 common and 1 plus K, right? K and this symbol, this is basically saying that K is represented by a normal distribution with mean 0 and standard deviation 1. That symbol, that tilde function is basically, K is defined by normal distribution, right? That is how you read it. All right? Is this clear? Why did we take K as normal distribution? Because, generally people assume that returns are normally distributed. So this was our formula, P0 plus P0 into K. So come to think about it, P1 is equal to P0 plus 1 plus K, or K is equal to P1 minus P0 divided by P0. So this is basically the returns, right? K is the return and K is normally distributed. So this is the intuition, right? Right? And it's an assumption. Absolutely, it's an assumption. So then I can do multiple simulations, right? So say I assume that the returns are normal with mu is equal to 0. This is the mean. Standard deviation is equal to 0.02. And I can run multiple simulations where K is a random number. So it will with each simulation, it will take any random number, right? For each simulation, each day, it will take a random number. And this is how the simulations will look like. Now, very interestingly, this is sort of similar to what a stock price looks like, right? Very similar to it. So basically, this model is somewhat similar to a stock price, but this is a very, very naive model at that. Right. Now, I want to tell you this one important thing which will be used in option theory also, and it will be used in this also. Variance is additive. So the standard deviation is additive. So if I say that, there's a stock whose daily return is, say, 1%, right? And daily standard deviation of returns is, say, 2%, right? If this is what I'm saying, and my objective is to calculate the standard deviation of so I need to calculate the returns and standard deviations of a year. Then how do I do it? Right? My objective is to calculate the return and standard deviation of a year. And this is given to me. This is given. How do I do it? Returns is very simple. Oh my God. Returns is very simple. If daily return is 1%, then yearly return would be is 252 into 1%, right? It's 252 trading days, right? So this is pretty easy. How do I calculate the standard deviation of a year? For this, remember, what I assume is that the standard deviation for each day is 2% and the returns of each day are independent of the previous values, previous returns. If this is the case, then what I can do is variance of 252 days is equal to variance of day 1 plus variance of day 2 plus so on till variance of day 252. Right? This is what I get. So this is the important thing that I should know. If this is true, then variance of 252 days is equal to, what is the variance? It is simply 2% square plus 2% square till 252 times, or this is 2% square into 252, right? So this is the variance of a year, and therefore the standard deviation of a year is square root of this. Guys, is this clear? Yes or no? Yeah, yearly return would be 252%. Is this clear? Standard deviation of a year? Yeah, pretty simple stuff. So the thing to be noted from this is that variance is additive. All right? Variance is additive if I'm assuming that for each period it is independent of the previous event. If I know this, then I can say that volatility of time period, so I'm taking 365 here, you can take 252 or 365, whatever, but the concept is that variance is additive. The key takeaway then becomes that volatility of time period t is equal to volatility of one time period into square root of t, right? Because variance is equal to n times variance or t times into variance of one time period. Therefore, standard deviation becomes square root of t into standard deviation of one time period. Is this clear? Guys, is this clear? Yes or no? What do you want me to repeat? What is not clear? Standard deviation of, so standard deviation of year would be, so variance is then basically T, so 252 into variance of 1 day, so T into variance of one time period. So I'm just taking the square root on both sides. So standard deviation of, so variance of T time period. Right, standard deviation of T time periods. Right? Where do we get the figures from average daily returns and daily standard deviation? Average daily returns, you can take the data for each closing day, right? So closing prices for each day, you can calculate the returns and you can calculate the standard deviation. Right? Variance is additive only for independent variables. So if there are two variables who are independent to each other, then variances, we can add the variances. Right? So, no, even if in historical data, if we calculate the standard deviation of daily return, then we can assume that, I mean, it's a rough assumption, but we can assume that for each day, the standard deviation was independent, right? And it was the same. So this is one of the biggest assumptions, but it's all right. I mean, you have to start somewhere, right? So it's a decent assumption to make, right? No. The square root of t. So maybe this is more clear to you, right? Is this clear? All right. So is this clear? Yeah? Great. So then what I can say is, if this was my formula, right, P1 is equal to P naught plus K P naught. If my average or my mean was mu for one time period, then my mean for T time periods is mu T, and my standard deviation for T time periods is sigma root T, right? And if I assume that this is following a normal distribution, then 95% of the times the return will lie between mu T plus minus 2 times the standard deviation. The standard deviation is sigma root T. So this T time periods can be 252 days, right? If this T is equal to 252, then this is sort of annualized, right? So it would be square root of 252 into the standard deviation of returns of daily returns. Right, Charles? Right. So in this case, I would say that, so the standard deviation of a year becomes this, right? So I can say that there is a 95% chance that the returns of the stock that the annual return of the stock will lie between 252% plus minus 2 times the standard deviation of the year. 0.31. Right? Is this clear? Is this clear? Yeah, this is, oh, sorry. No, this is 95%, right? 2. So there was a 68%, this 2 would have become 1, right? So this 2 part is actually what the 95%. A lot of Bollinger bands are actually based on this. So if the price goes beyond this 95%, on the upper side, people short. If the price goes below this 95%, then people long the stock. So this is a strategy from Bollinger Band, simple Bollinger Band that people make from the historical data, and this is how this is a mean reverting strategy. So there was a 95% chance that the stock should lie between this range. If the stock goes beyond this range, then they long or short accordingly. Is this clear? Yes or no? Guys, all right. So should I move ahead? All right. This is a simple question. This is the probability distribution of two stocks, stock X and Y. The red one is X, this pink one is Y. Which stock is riskier and why? If there's a question, if everything is mean reverting, then why do stocks go up? So, as I said, right, I mean, no. So, no, my friend, you forgot that there was a 252% plus minus. So this 252% is sort of, it will go up, right? This 252% is saying that it will go up, but the stock will sort of move around this 252%, right, Sumit? So everybody knows that stock Y is riskier because the mean of both stock X and Y are the same, but the standard deviation of stock Y is more, right? So this is clear to everybody, right? So should I move ahead? All right. All right. By the way, any question? By the way, from this point, I usually take half an hour more. So it is 6:50 by my watch. So we'll close by 7:20. I really apologize for this. But then, it's always time taken and questions answered. So if I'm answering all the questions, then, the time taken is more. So it's a play between that. I apologize to everybody up front, but we are sort of half an hour or 20 minutes late. All right. So I hope till this point everything is clear, yes or no? Yeah? Great. Great. Now coming to the last part of this lecture. So, let me just recap what we've learned so far quickly. We started up with how to visualize the data, how to summarize the data, samples, populations. Then I told you about probability theory, addition rules, independent rules, multiplication, Bayes theorem, right? And then I moved on to, how do I calculate the means and variances of a portfolio, right, of two variables. And then I introduced you to the concept of normal distribution, how we can model a stock. And once we know the mean and the variance, and I assume a normal distribution, then I can sort of simply model a stock price, right? Yeah, I told you this is sort of a lecture which starts off easily and then it builds up, right? But don't worry, it's, I would urge you guys to sort of go back and sort of go through these slides again, and it will be very easy. Once you go back and revise this lecture, everything will just sort of settle in, right? So don't worry about all this. Variance is additive, standard deviation is not, right? All right. All right. Why do we need to model the stock price? Why can't we take it from historical data? Because we need to predict, right? We need to predict, we need to forecast for the future. So we need a model to predict, right? Historical is fine, but we need to predict, right? All right. So regression. So we'll just talk about a linear regression model, right? Linear regression simply builds a relationship. It tells me the relationship between two variables. If I know the value of one variable, can I predict the value of the second variable? This is what linear regression tells me. This 252%, that was just an example, guys, please. All right. So linear regression. So what I have is, I have prices of State Bank of India, daily closing prices of State Bank of India and Punjab National Bank. And I need to figure out a relationship between the prices of these two banks, right? These could have been anything, Microsoft, Google, State Bank of India, for that matter, any index, right? S&P, Dow Jones and whatnot. So what I do, I plot. So I want to predict Punjab National Bank if I know the value of State Bank of India, right? So I predict, I plot the values on x-axis, y-axis. Y-axis is the one that I want to predict, right? So I want to predict PNB from SBIN. And this is how the plot looks like, right? Now what I can do is I can draw various lines through these points, right? I can draw various lines. Right? I mean, seemingly infinite lines that sort of go past these points, right? But, and then I draw these lines, and what do? I calculate the distances of these points from that line. So when I'm plotting these lines, I am calculating these errors. And what are the errors? This error is the sum total of the distances of these points from this line, right? And there would be one line which gives me the least error. Or in other words, the distance, the sum of the distances of these points from that particular line would be the least. And that line is basically the equation that I call is the best fit line, right? And I can calculate the equation, and the equation for this is y is equal to 0.8236 minus 82.552. This is linear regression for two variables. And I think in next class we will learn more about regression, but this is simple linear regression of two variables. Is this clear? Guys, you can hear me, right? All right, great. So, is this linear regression? I mean, is the concept of this best fit line clear? So I'm just plotting up these points, trying to find out the line for which the distances between the points and this line is the minimum, and that is the best fit line, right? And once I have that line, I can plot the equation, right? I mean, I can know the equation. So this equation is y is equal to 0.8236x minus 82.552. In other words, this equation is telling me that if I know x, if I know the price of State Bank of India, price of PNB would be 0.8236 into price of State Bank of India minus 82.552. Yeah, this is exactly what the least square method does. Right? But we don't need to, I mean, Excel can simply give you this line, and I will show you how to find out this line easily. But this is what the best fit line does. I will tell you how to get this equation. This is not a big deal. I will show you how to get this equation. Right? No, what So, now there's a question, shouldn't these error lines be perpendicular? This is a very good question. There are two ways of finding this line. One is where the distances are perpendicular, one is they are absolutely vertical. And, you can sort of, there are pros and cons of this. In this, we take vertical distances, right? But this is a good question. You could have done it perpendicular also. That's a good question. But, that's one step ahead of it. But so right now, we'll just assume that we are taking vertical lines, right? Yeah, so this is the predicted value of y, right? Now, it would be more appropriate if I do returns. That is correct. But, I just wanted to, ideally it should be returns, but, to keep things simple, I'm doing prices. And, Nathan, let us not jump the gun. Anyways, we are, sort of racing against time. So let me just complete it and, let us keep the questions related to what I'm telling you. And then, as I go ahead, most of your questions will be answered. So the interesting thing is that what are we trying to do here? We're trying to predict y through x, right? We're trying to predict y through x. Now, if x was not there, right? If I didn't know, there was a relationship between two values, then I would have predicted, and, somebody asked me to guess the value of P and B, right? My best guess would have been an average, right? My best guess would have been the average. So, if I don't know the values of State Bank of India, if I only have Punjab National Bank's values, and somebody asks me to, to sort of guess the price of Punjab National Bank, my best guess would be an average of the prices, right? But with X in picture, I can predict it better, right? And there would be less error if I use X to predict Y than if there was only Punjab National Bank, right? But you don't know X. No, I know X, right? X is the price of State Bank of India. So I know X. And I'm trying to predict Y from X, right? Is this clear? I'm not predicting X. I know the value of X. So here the point is, if I know the value of X, can I know the value of Y? This is the question. I'm not predicting X. I cannot predict X, frankly. Is this clear? Yes or no? So X, right? And now, there's a parameter called R square. So, this, you don't have to worry about this table. You just need to know two things about this, right? One is that there's a term called R square, and I will tell you how to do this regression on in Excel, right? So don't worry about it. But first, the theory. So this R square actually tells me how good the fit is, right? So if the errors were really less, then this R square would be high, right? So this R square is basically two terms, right? Numerator and denominator. Numerator is my predicted value minus the average of the actual observations divided by my x minus the average of x plus. So this what you should remember is that this denominator has this sum of errors, right? So if the errors is low, this R square would be high. And this is pretty much it. I mean, the takeaway from this slide is that if the errors are low, the R square is high. So basically what we need, whenever we are doing this regression, we need to know that we need to concentrate on the R square value. If the R square value is high, then our regression is good. All right? Is this clear? What do you want me to explain one more time? So here, all I'm trying to tell you is, we need to predict y through x. How are we doing it? We are plotting them on a graph. We are drawing lines. We are trying to, we are calculating the errors of the point, the distance of the points from the best fit line. For the best fit line, these distances are the minimum, right? There's one line for which these distances would be minimum, and that is our best fit line. We know the equation. From that equation, we can predict the value of y from x. You know, residual and R square, don't worry about residual and R square. The only thing I'm telling you, right, the takeaway from this slide is that if the errors are low, the R square is high. You don't need to care about F ratio and degrees of freedom and whatnot. P value I will explain. But if the errors are less, then the R square would be high. Right? How are we able to draw PNB and SBN on the same graph? Dude, this is simple graph plotting. So for 250, so this is like x comma y, right? I mean, you can do it in Excel. When I use the term predict, you mean that you need to know the value of y in the future. Not really. When I'm saying predict, I need to know the value of x. If I know the value of x, I can predict the value of y. This is not future. Time, I'm not taking time as a variable here, right? This is simple regression between two variables, x and y. If I know x, I need to estimate y. Right? Okay. Now comes the slope or beta of the stock. Beta is basically a measure of a stock's volatility in relation to the market. Right? What does this mean? For a given asset and a benchmark, the goal is to find an approximate formula. RA is equal to alpha plus beta RB. What does this mean? This is somewhat similar to y is equal to mx plus c, right? This, what is this beta term? Right? If, so in RA is equal to alpha plus beta RB, if the returns of a benchmark, asset B, right? Excuse me, is say 1%, right? Then the return of asset A will also increase by beta %. That's what the beta of the stock is, right? Yeah, people call this CAPM and whatnot, but just try to, what it is called is not important, what it does is very important, right? So return of A is equal to alpha plus beta times return of B. So if B has a return of 1%, then return of A will also be beta % plus alpha, right? This is what it is saying. What is alpha? Alpha is basically, so y is equal to 0.8236x minus 82. This 82 figure is the alpha. And this 0.8236 is the beta. All right? Now, and there's another formula for beta. Beta is equal to covariance of RA RB divided by the variance of RB. Right? So, now comes to the practical aspect of it. So we had this. You guys can see the Excel. Yeah. So I have returns of index and returns of ACC, right? And guys, please pay attention. I need to predict ACC by NSE, right? This is what I want to do, right? How do I do it in Excel? I go to this data tab, data analysis, right? I'll show it to you again. Data tab, data analysis. And I choose regression here. Regression. Input Y range, I put ACC's data. Input X range, I put Nifty's data. I press OK. Right? So no label. So I press OK, and this table automatically gets formed with an X variable and intercept. What does this mean? This equation, remember, equation of a line is m into slope into x. This was the equation of the line, right, from our high school. Or ACC is equal to m. M is the x variable, 0.076725 into Nifty plus this C. C is this intercept, 7.78 E minus 5. This is the equation. This is how Excel will do it for us. Guys, is this clear? So this is how I am predicting ACC. Mind you, I did it on returns, right? So somebody was saying it should be done on returns. I did it on returns. And this is how I am predicting ACC returns. Daily returns would be 0.076725 into Nifty returns plus an intercept. So this 0.07 guy is basically the beta. This thing is also the beta. Is this clear? Yes. Beta is 0.767. Any questions on this, guys? This is the best fit line. Absolutely. This is the best fit line. From the graph, you can also do add. So if you have this graph in Excel, you can do an add trend line. You can select these points, add trend line, and you can say, display equation on chart, and it will display the equation, right? So this is how you can do it on a graph. If you have a graph, just select the points and right click, it will show you add trend line, and you can do it. Right? So this is doing it graphically, and this is doing it theoretically. What do you mean how to plot? So you can easily plot this graph, right? I mean, just select this, insert, scatter, and this is how the plot looks like, by the way. Right? So you can do this and whatnot, right? So see here, it is exactly the same, right? 0.067. So I can move it to I can move a chart. How can I do it? So move chart to a new sheet, and so this is it, right? So it is exactly the same, right? You can do either ways, Nifty, ACC, ACC, Nifty. By the way, index moves first. So yeah, anyways, I'm just saying, I mean, you can do whatever. So these are basically the same, right? So the line is giving you the exact same equation as our data. Is this clear, guys? Intercept is the alpha. Alpha. So, you can think about this as intercept is basically, so beta is dependent on the market, right? Beta is dependent on the market. Alpha is of that, the characteristic of that stock, independent of the market, right? So the stock returns are divided into two parts. One, its innate nature, and second, how it reacts to market conditions. So beta is how it reacts to the market conditions, alpha is its innate nature, right? This formula to calculate the regression line, so I've already told you, right? You can go through the lecture again how I did it. So this is how you do it, right? Yeah, this is the CAPM equation also. This is exactly the CAPM equation. All right? Any question that I missed? All right. So if this is clear, then now back to the final part of the PPT, how to interpret this result. So we've got these very nice results, right? Betas and alphas. But how do I really interpret? Are these statistically significant? What's R value here? So R you can actually calculate from the graph. So you can, what you can do is, so this was a chart, right? So when you are adding a trend line, you can say display R square also on the chart. So the R square is pretty bad. Right? So when you add, right click on the plots, add trend line, and you can say display equation and display R square on the chart. All right? Is this clear? Yeah? Great. What's a good R square value? It depends upon the data. Anything above 0.5 is good. In real life, 0.5 is very good. Above 0.5 is good. All right? In real life. Right? All right. So understanding the P value. Now I need to, so this is the final part. I'll take another, I'm sorry guys, I'll take another 15 minutes, but it is what it is, right? At the cost of clarifying all the questions. Just give me 15 more minutes and we'll be done. And I sincerely apologize. All right, understanding the P value, right? Now, the question over here is, so, what I usually do is I take an example to make you understand what this P value is. The objective is to sort of figure out whether my statistical results are correct or not. Whether this value of beta, this alpha that I've got are correct or, they are statistically significant or not. So what do I do? I check there's something called a P value and I check that P value. Now what is this P value? Now what I do is, so say I have a coin, right? So in my example, I'll just explain this you with an example and everything would be clear to you. So what I have is, I have a coin, right? And I don't know whether this coin is fair or it is biased, right? So I don't know this. I need to figure out somehow whether this coin is fair or this is biased. Is the question clear? Is the question clear? So I have a coin. I don't know whether it is fair or biased. I need to do something, conduct some test to figure out whether it is fair or not. What I do is, I toss it 10 times and I note the number of heads that I get. Alright? Very simple. I toss it 10 times and I note the number of heads. Now, interestingly, I know for a fact that if the coin is fair, then I know exactly what is the probability of getting no heads, what is the probability of getting one head, what is the probability of getting two heads, what is the probability of getting 5 heads, 6 heads, 7 heads, and so on. Right? Yes or no? Guys, yes or no? I don't know whether the coin is fair or not, but I know for a fact that if the coin was fair, I can easily calculate the probability of the number of heads that I would have got if the coin is fair. Yes, guys, are you with me? Or have you guys just slept off? No, already you guys are with me, right? So now, what I do is, I make an assumption. Before tossing the coin, I make an assumption, and my assumption is that so there is a 5%, even if the coin is fair, there is a 5% probability that I toss the coin and the number of, I'll get 9 heads. Out of 10 tosses, I'll get 9 or 10 heads. There's a 5% probability, right? Even if the coin is fair, there's definitely a chance, right, that I toss the coin 10 times and I will get 9 or 10 heads. So before tossing, I say to myself that, you know what I'll do, I'll toss it 10 times, and if 9 or more heads come out of those 10 tosses, 9 or 10 heads come, then I will reject this coin as fair. I will say that, you know what, this coin is not fair. I mean, yes, there's a chance that even though the coin was fair and, I would have gotten 9 or 10 heads, but for simplicity, there are more chances that if the coin is biased, then I will get 9 or 10 heads, right? So this is my assumption. My assumption is that this coin is fair, and this is called the null hypothesis. My hypothesis is that the coin is fair, right? This is called the null hypothesis. I will toss it, I will conduct a test. If the result of this test is such that there is a very less probability that the null hypothesis was true. If there are 9 or 10 heads, then there was only less than 5% chance, right? If the coin was fair, there was a less than 5% chance that I will get a 9 or 10 heads, right? If I get 9 or 10 heads, I will reject this coin, I will reject my null hypothesis, and I will accept that this coin is fair. Is this clear to you guys, yes or no? So that's what I'm saying, right? My assumption is that the coin is fair. And this is the null hypothesis. That the coin is fair is my null hypothesis, right? So my starting assumption, what is my starting assumption is the null hypothesis. In this case, null hypothesis is that my coin is fair. Alright, is this clear? I will repeat it again. So one of you guys is asking me to repeat, so I will repeat it. And pay attention. So, okay, I'll just repeat everything, right? See, this is why we take time, right? But that's all right. I mean, frankly, I don't mind if you guys don't mind, right? So I'm here, right? Okay, so what do I have? I have a coin. I need to know whether it is fair or not, right? I need to conduct a test to figure out whether this coin is fair or biased. What I do is, I assume that the coin is fair. So this my starting assumption that the coin is fair is my null hypothesis, right? And I toss the coin 10 times, right? Now what I look at it is, if the value of my test, right, has given that my null hypothesis is correct, if the probability of my test comes out to be less than 5%, say, 5% is a random number, and this is frankly this is set by me, right? I am setting that if the value of my test is, the probability of the test that came out was less than 5%, if the null hypothesis was true, then I will reject my null hypothesis. So in this case, if I get 9 heads, if I toss the coin 10 times, if I get 9 heads, right, the probability of getting 9 heads if the coin was fair is less than 5%, then I will reject the hypothesis. In all other cases, if the number of heads was 5, 6, 7, 8, 4, I will accept that this coin is fair. Guys, is this clear? Guys, have you understood this? Now coming to the technical terms, my starting assumption is the null hypothesis, right? There is a type 1 and type 2 errors. What is a type 1 error? Type 1 error is very simple. Even though if the coin was fair, it is possible that I would have gotten 9 or 10 heads. But you know what? Because I've gotten 9 or 10 heads and I had already stated that, you know what? If 9 or 10 heads come, then I will reject it. So even though the coin is fair, I reject it. Right? I reject it. That's fine. I mean, I rejected a fair coin, but what can I do? It is what it is. This is type 1 error. Type 2 error is most dangerous. It's quite possible that the coin was biased towards head, but in this test when I tossed it 10 times, only 5 heads showed up by chance. Usually it was very, very biased towards heads, but in this case, only 5 heads show up, so I will accept it. This is type 2 error, accepting a false coin, right? I mean, so a false statement, right? So I could not, even though my null hypothesis was wrong, I accepted it because my result came out that way. Is it clear? Yes, so chances of 0, 1 or 2 heads is also less than 5%, so I will reject it. So if 0 heads come, then also I'll reject it because the chances of that happening was less than 5%. Guys, is this clear? So this is about p-value. So p-value, right? P-value is basically the probability of observing of value for a test statistic, observing the probability of getting 9 or 10 heads. That is as extreme or more extreme than the value we have calculated from our data, given that the null hypothesis is true. Whenever you have to understand this p-value, right, always think about the example. This is what I do. I always think about this coin example and everything is clear to me. So this is what it is saying, right, that given that the null hypothesis is true, given that the coin was fair, my probability of getting more than 9 heads or 10 heads, right? So if I get 9 or 10 heads, I will reject my null hypothesis, right? All right. Now, so this is, so when where did it go? So this is the p-value of the intercept and this is the value of the x variable. I will reject my null hypothesis if, say, the p-value is less than 5%. So in this case, I will reject it for x. I will accept the null hypothesis for intercept, yes or no? Guys, yes or no? Because the p-value for x is less than 5%, I will reject it. Because the p-value for intercept is above 5%, I will accept the null hypothesis. The null hypothesis, and this is very interesting, in statistics is that the value of that variable is 0. So if I'm rejecting the null hypothesis for x variable, this means I'm rejecting this null hypothesis and I'm accepting that this beta value is correct. If I'm accepting the null hypothesis for intercept, this means that I cannot accept this value of 7.78 into 10 power minus 5. The value should have been 0. So these are different p-values, right? P-value for intercept and p-value for variable, x variable, right? These are two different variables, so these will have their own p-values, right? The null hypothesis is that the value of this variable is 0. For both. Of each variable is 0. Alright? Yeah, these are two separate. So these are two separate null hypotheses. So in this test we ran excuse me, we had two null hypotheses, that the intercept is also 0, the x variable is also 0. But for x variable the p-value was less than 5%. So I reject the null hypothesis. For x intercept I cannot reject it. No, it is not always 5%. It's up to you. You can take 2%, you can take 1%, you can take 10%. Usually people take it as 5%. It's up to you. You can take 10%, 5%. Yeah, absolutely, right? I mean, you see, at the end of the day, you don't want it to be high as 95%, right? I mean, because if it is 95%, then just think about the example, right? You are essentially saying that you will reject everything, right? I mean, you'll reject each and every coin because, right? I mean, just try to think about it. What will happen in that coin example? The p-value should be lower. The p-value should be lower. See, always try to relate it with the example, right? When do you want to reject the coin? When the test comes out to be say 9 or 10 heads, right? When the probability was really low for that value to come, right? For the value for 9 heads or 10 heads showing up, the probability was very less, right? That is when you reject it, right? Yes, intercept is completely off. So I will not, so this is not statistically significant. Intercept is not statistically significant. I will reject the null hypothesis only in x variable. Or in other words, this graph, this equation would now be, this is the correct equation. Right? This is the correct equation. Because I need to reject only x variable. Right? So by the way, this class is officially over. I'm still here obviously to answer your question. This is a problem that you can attend for self-study. I'll take questions so that people who've understood can leave. So this is finally the end of the class. Boy, half an hour more, right? So you can calculate the rolling day variances and returns of 50 stocks. You can, this is self-explanatory. Choose 10 lowest volatility stocks, allocate equal capital for each 10 stocks and returns for this portfolio. You can calculate the betas, choose 10 lowest, highest beta so that the net beta is 1 and then calculate the return. So this is for self-study. This is officially the end of the class. So I'm still here for people who did not understand any concept in this lecture. I'm here for another 10-15 minutes. Right. So for people who've got it, you may leave. Officially, this is the end of the class. Right. All right. Now I'll take questions. How do we interpret in this example? So we can interpret this example as that, because the p-value for x variable is too low, right? We need to reject the null hypothesis. And the null hypothesis is that the value of each variable is 0. So we need to reject this null hypothesis and we need to accept whatever values we got from our regression tests, right? This is the interpretation. So intercept is not useful in this case. That is correct. So if p-value for x variable is less than 5%, the coin is fair. No, my friend. No, my friend. You are getting confused. So let me. Okay. So in the coin example, my null hypothesis is that coin is fair, right? If p value comes below 5%, I reject my null hypothesis. Right? This means I reject that the coin is fair. Right? This is the coin example. In my statistics example, regression example, my null hypothesis is the values of variables is 0. So if p value comes less than 5%, I reject. This means I accept the values that I got from my statistical analysis, and I reject the assumption that the value of the variable is 0. Is this clear? Thomas, is this clear? Compute the drawdowns in each case. Forget that drawdown. I will cover drawdown in my strategy class, right? So trading system class. So forget the drawdown. Just compare the returns and volatility, right? All right. One of our friends is not clear about the p-value for beta and alpha. Why do we need to see for both? So my friend, you are calculating the value for both beta and for both x variable and intercept, right? So these are two variables. You are calculating the values for both. So here we had two hypotheses. X variable is also 0, intercept is also 0. So we need to know which one to accept and which one to reject, right? I mean, take them as two independent tests, right? It's like we have two coins. So we have two null hypotheses. Which one would we accept and which one will we reject, right? If I rerun, I will get another p-value. No, not really. I mean, for this same data, this p-value will be exactly the same, right? I mean, yes, in the coin example, yes, it could be different, right? But it's like, it's like you have been given one data, right? So for that one set, this p-value will be the same. If you run another period historical data, yes, this p-value could be different. So if you have different historical data, then obviously it would be different. Why did I reject? I accepted intercept, my friend. Here I rejected x variables. Pay attention, guys. Variables, null hypothesis, and accepted intercepts, null hypothesis. Right? So because I rejected the null hypothesis for x variable, therefore this value 0.076 was correct. Because I accepted intercepts, therefore null hypothesis, this intercept value should be 0. I will share the Excel. All right. So how did our null hypothesis improve our regression analysis? It did not improve our regression analysis to say. It just told me which value to accept and which value to reject. It's as simple as that. Right? So it did not improve the, it just told me out of these two values, which one should I accept and which one should I reject. Right? It's as simple as that. Right? Both the variables were normal. Were there any other assumptions made? No, in this I didn't assume. In my linear regression, I didn't assume that they're normal, first of all. Right? I mean, I'm just trying to find the best fit line. Right? That's all I'm doing. There's no assumption to say. Right? If I want to calculate the p-value for running 15 days data for the month, is it possible in Excel? Absolutely, right? So data analysis, regression, right? Do it for 15 days. So this is 15 days, right? And then similarly for input also, right? So you can do it, right? I mean, I did it for the whole period. You can do it for whatever time period you want. Right? Is it possible that I reject both x and y? Absolutely. You can reject both x variable and intercept. There are many cases in which you'll have to do that. How you defined null hypothesis? This is how linear regression and p-values work in statistics. This is your null hypothesis. In all these tests, statistics tests, this is your null hypothesis. No, you will not have 15 tables. No, my friend. If you want to run it for each day, then yes, different. But remember, I ran it for 2, 4, whatever. I ran it for how many days? For 2, 4, 6, 7 days, right? And I got one table, right? So it's like saying when I ran this regression, I had one equation for. So I had how many days? So I had like this 15 days, right? And I had one equation for this 15 days data, right? Aditya, is it clear? All right. Any question that I missed? Any question that I missed? I'll take another 2, 3 questions. Yes, for the final equation to be successful, you would want to reject both the intercept and x variables null hypothesis. If x p-value is higher than this, yes, then we assume that x is 0, and frankly, your equation just does not hold. Your analysis, you can reject your analysis. Yes, then I will, yeah, that is correct. I will not use this formula then. All right, guys, it's 45 minutes past the official time. I sincerely apologize, but the only saving grace is that I really hope I've answered all your questions, right? I mean, I always say this, right? A class is as good as the slowest student, right? I mean, it's fine, right? I mean, and we need to cater to each student, right? And I've tried my best to cater to those questions that were relevant, but still, sometimes I have to repeat the same thing a lot of times, and it just magnifies. Yeah, I need more time then. So, I really apologize for this, but I hope that everything that was taught was clear. If there are any questions, please feel free to email me, set up a call. I'll be more than happy. I apologize to support and to Jay. I know it's pretty late here, but it is what it is, right? Yeah, you can absolutely call me next week. I'm usually available after 4 o'clock in the evening. Any weekday is fine, right? Thank you so much for attending the lecture. I really hope this was helpful. you will not see me for another 2 weeks, I think. Right, and I will finally take my last lecture on trading systems where I will cover the rest of the stuff. Thank you so much. I really hope you have a great week ahead. All right.